Hey, welcome everybody. It's January 5th, and that means that it's a new year, right? I think we finally left 2021 behind, and we're walking feverishly into 2022 for some reason. We're just persisting in this thing that we have to do, I guess. But it's the new year, and the holidays were just here. I hope you all had a great holiday season, and we're going to say hello to a bunch of friends and familiar faces and screen names in the chat room. We have a few familiar faces this direction. Yes, down here. And so we'll get to interviewing or introducing everybody, which most of y'all know who everybody is. But let's get to that, and then we'll talk setups, because a lot of people probably or maybe have gotten some new gear for Christmas. Maybe you got that new telescope you were wanting. Maybe you have no idea how to use it. Hopefully we can provide some insight to that. We're going to talk about that and a bunch of other things, but we have Mr. Joe Califf at the Astro Joe right here next to me.
Everybody, how's it going? Will, Bram?
Good to see you, man. Thanks
Likewise.
For organizing this, Joe. Joe did all the flashy stuff you see around you. So
yeah, look at that. I actually had to take pictures of No, I'm just joking. Didn't have to take pictures of fireworks, but no, it's good to be here. Like you said, glad that we're turning the corner. We've turned the corner on 2021. We're in 2022 now. Hoping for a much better year, and what a better way to start than to talk about new astronomy equipment, right?
Yeah, and here we are. I think all of us on the panel got some new gear,
Yes.
Which, you know, some of it is in transit maybe, or some of it is already here. So we're going to talk about that. And another guy that's on this thing that does have some new gear, obviously, he's got a microphone in his face this time. Mr. Bram Wiseman at the Immature Astronomer. What's up, Bram?
Hey, it's good to be here, Will. Thanks for putting this together, you and Joe.
Yeah. Well, it was actually Joe. I'm very lazy, and I do as little as possible. So,
hey, blame me. I said, we were on the phone the other day, and I said it's been way too long since we've had a live stream like this. So let's do something. We just got out of the holidays. Like I said, what better than to talk about this? I mean, there's a lot going on in the astronomy world right now, especially with the launch of the James Webb. But I want to see eyepieces. I want to see new telescopes that are here on the ground that people are going to be using. And then in a couple months, we can take a look at all the cool stuff James Webb is doing.
Yeah, and I don't agree with this statement, Mark.
I'm not Mark.
L2. I'm not on my way to L2, but if I could make that sacrifice for y'all, I probably wouldn't. It's good to see you, Mark, as always. Hello, Kenny. How you doing? Mr. Hunter Ackerman is here. Good to see you, Hunter. And hopefully those of y'all that did get some new astronomy gear, get some pictures or go find the link to whatever you got or whatever you bought. And we would love to, like I said, see the stuff so we can maybe help you maybe with some initial advice, right? That's kind of why we're here. Joe's an expert on every optical design that is out there.
Yes.
If there's even one iota wrong with it, he can diagnose it with math. So
that's it. Yeah. We'll take a look at field curvature, the parabolic curve of, the mirrors and lenses and whatnot that you have. So yeah, I've got my slide rule ready.
Throw out a straw number.
If it's less than 0.95, it's crap. Throw it out.
And those straw numbers get real weird, and I'm not even really sure what half of them mean half the time. But
right, I'm sure half of them are made up too, right?
Where should everybody post their pics?
Well, they can post them in the comments section of Facebook, but I don't think it'll show us on here. So we'll have to, if somebody does post pics, we will have to open up that stream and just go look at it. And we could probably share screen and get it on that, but you'll probably have to share it on Facebook, or you can send it to my email, thedeepskydude@gmail.com. And I'll be checking that periodically through the stream so we can make sure everybody gets their stuff in. Or like I said, if you just know what the scope is, you can type it down in the chat, and we can go online and find a picture of the thing and try to give you some advice. I know a lot of people get box store scopes at this time of year. The stuff you find at Costco or Hobby Lobby or whatever. So we'll do our best to work with those. But if you are somebody that got a new camera or a new, like Joe said, an eyepiece or something, that is also fair game as well. So looks like we got a lot of people in here hanging out.
Yeah, Will, I was going to also say, if people want, they can tag you, post the photo if they're Instagram users, post it online, tag at Deep Sky Dude. I posted that there in the chat. So we'll take a look at that and see if anybody has any new photos of the gear that they have, and we'll share it online as well.
Absolutely. Yeah. And we will talk about James Webb tonight. There's a
oh yeah,
a website we should definitely all get everybody in tune to, and we'll show that in a minute. And we'll also go ahead and show, I've got Sky Safari set up in the back, so later on, I can actually show you guys where you can go point your new telescopes to the sky, and maybe you can even catch a glimpse of James Webb on its way out to L2, because it is doable. People were doing it in those toy unistellar scopes, those $3,000 toys they have. People were doing it.
Endorsement deal coming, right?
Yeah, absolutely. Yeah, send me one. So yeah.
I'd
well,
like to answer Cheadle's question here. She wants to know opinions on the Webb telescope.
Yeah.
I think it's a great telescope. I think everybody should have one. I hear they're on back order though.
Yes.
So you should get your order in now. It's going to be a while.
Supply chain affecting everything, right? So yeah, getting your own James Webb telescope's a little tough right now. But no, in all seriousness, look, I've said this to anybody who will listen. I still think the greatest scientific tool, single tool that has ever been developed by humanity was the Hubble Space Telescope. And my expectations for the James Webb is much, much greater than that. So the capabilities that it has in peering into that near infrared far outshines anything Hubble is capable of doing. And I just can't wait to see what we discover with it.
Yeah, this is an exciting time for sure.
Yeah, and it's almost there. The secondary mirror was extended today. I think that's what they said.
Yeah.
The full sun shield has been deployed. So I think we're at the stage where we unfold the 6 mirrors on the side, right? And bring the full parabola out. Just a few more housekeeping procedures after that, which should happen fairly quickly here. It's been, I remember looking at the timeline before this thing launched. I'm like, man, this is going to take forever. But when you get past the thing, it kind of happens just in the background while we're all living our lives, and it's actually happening pretty quickly. So that's very cool.
Well, and one of the other cool things is I think this mission had an effective lifespan of about 4.5 to 5 years. But because, fingers crossed, everything's gone so smoothly, they've saved enough fuel that they anticipate being able to, should everything go right, get 10 years out of it now. So that's awesome.
Yeah, I think it was 10 plus actually.
Yeah,
10
my
plus,
my understanding was like 5 was the minimum for it to be sanctionable.
Right.
But they really were designing it for 10 years. And now that they had such an efficient launch and everything, very minimal fuel burns and whatnot for corrections, they say they're going to go well beyond 10 years.
Yep, absolutely. And I'm just going to keep monitoring while we're going, guys, to keep making sure nobody's sending pictures. So if anybody is, then hopefully, and y'all can message that to me too. If you're on Facebook watching us, you can message that in on Facebook as well, and we can get those. It looks like my buddy Hunter had a question, which is an interesting one. What do you recommend for looking at my hot neighbor in the building across the street? Hunter, my recommendation on that is don't do it.
Don't do it.
But don't do it. And it's funny because Hunter used to live like way out in the California countryside, but I think now, correct me if I'm wrong, Hunter, he's back down in I believe it's like Playa del Rey, somewhere down there, somewhere in that nice little section of California. So
nice.
Yeah, that's pretty cool. Mark Jackson says Lego should release a James Webb kit.
That might be happening, actually. Yeah,
I saw one, but I don't think it was official. Maybe
no. They've got this thing where fans can, make a build and put it on a site, and if it gets enough votes, then it may actually be built into a kit. And I saw 2 different James Webb telescope prototypes there. One of them's okay. The other one's really awesome, and that awesome one's already met the required number of likes. So it could happen. It's really sweet.
Yeah. And so it was probably that same one that I saw, maybe, Bram, where the guy was kind of unfurling it in the process, I guess, like as it went.
Yeah, the cool one actually has hexagonal mirror elements. They're made up of little triangular pieces. The not so good one has little round mirror segments, and there's too many mirror segments. It's just really janky.
Well, we got to have accuracy, right?
That's
we got to have ultimate accuracy. Absolutely. So, well, let's talk gear.
So, Will, yeah. Anything new in your life after the holidays from a gear perspective, or?
Yeah, I got a new one of those things, but that's a subject for a different day.
Astronomy gear.
I promise next time I do a live stream, it'll be there. So we'll talk about that when that bridge is crossed. But one thing
Supply
I did
chain
get,
issues, though, man.
Well, what's funny is I got on an email list with my favorite music store online, and I was like, "Hey, tell me when this guitar is in stock." And they emailed me at like 3 a.m. and I woke up the next morning and was like, huh. So I called my sales engineer over there and I was like, well, how many did y'all get? Y'all get a few, 3 or 4 of these green ones? And he was like, we got one. And I was like, oh, okay. I'm going to go ahead and get it then, so. And so thank you, Dennis. He gave me a really good deal on it, by the way. But as far as astronomy goes, I got this, which is a nice shiny yellow box. And that's all it is. So I'm just kidding.
Nice.
Inside this box, which is cool. This is what they ship this thing in. This is going to, let me not try to knock stuff over in here. This is going to revolutionize my solar observing. See if I can move it here. Right about there.
Look at that. And that is not some
it's not an
Disney
emoji
droid or anything else like that, right?
No. Those are knobs. They're not eyeballs, and that's a USB. I guess mini USB. What this is a Daystar Quark Gemini. Now, for those of you that are into solar observing, this thing is an eyepiece made for one star, and it's not really an eyepiece. Like, you couldn't put this in a telescope and then put your eye in here and see anything. You have to put this in your telescope and then put an actual eyepiece in, or a camera right here. And so Daystar is a company that makes solar telescope equipment, mostly in hydrogen alpha. This is a hydrogen alpha unit. But on their website, I guess maybe up until about a year ago, you could get 2 different versions of this thing. You could get the Daystar Quark Prominence, which is what hangs off the side of the sun, or you could get the Daystar Quark Chromosphere, which is kind of the surface of the sun, right? This one does both. And all you have to do is push this nice slide thing. It's nice and metal and has a nice click sound to it when it goes across. And it allows you to see the sides of the sun in hydrogen alpha, or the sort of the front side of it, as if it were, or whatever you want to say. It's powered. So that's what the USB is for. And these knobs help to fine tune the stuff. So this can go into any kind of refractor that you may have, which I thought was another huge selling point. I don't have to buy another telescope, just this piece. And I can't wait to do some solar time lapses on some prominences with this thing. I'm just kind of waiting for the good opportunity to do it. So there it is. Not an endorsement. I haven't used it yet, so I'm not saying to go get one of these. They didn't pay me to talk about this, but I got it like the day before Christmas Eve. So Merry Christmas, I guess, right?
That's awesome. Can't wait to see some of the photos that you post with that. I've seen some other friends who have those Daystar devices and whatnot, and the photos that they're getting are just incredible. It's amazing to see what just the average Joe like you, me, whatnot, what kind of photos and images that they can get.
The average Joe, there he is.
Yeah. But no, it really is incredible. I mean, we've seen some of our friends like Lloyd Overcash and Tim Pellerin and guys like that who are doing solar photography, and the images are getting blow away anything we're getting with professional telescopes just a decade ago. It's crazy.
The technology is getting easier and cheaper to get. And Hunter says, what is hydrogen alpha? So imagine you have the full spectrum of light in the rainbow in front of you. Hydrogen alpha is the tiniest little sliver at about 656 nanometers. Tiny, tiny sliver right in the middle of the red. And it just so happens that if you look at the sun in that hydrogen alpha filter band, in that 656 nanometer band, you block out all the other light except for that one little sliver. It shows you the solar atmosphere, even though there's no atmosphere on the sun, right? It's what's above the sun, like coming out of the sun. So massive, what you would consider solar flares, what we call prominences. You can see that kind of stuff hanging off the side and these massive storms that are bigger than Earth. You can still see sunspots and everything like that with these as well. Just appear a little bit different, but it's a wavelength of light that is very valuable to astronomy, especially if you're trying to figure out what the old sun is doing over there. So great question there.
Yeah, they use it also for, I believe, emission nebula too. So it's an important wavelength for observing some of the features there. Yeah.
That's absolutely right. Yeah. And with the night vision, you can get a hydrogen alpha filter, which is just a piece of glass, circular glass coated with hydrogen alpha filtering material. And you can, like on these night vision monoculars, you can see Barnard's Loop, California Nebula, the Heart and Soul. Crazy. I mean, I could sit here and go on, but y'all get the idea. Any red nebula in the sky, our eyes are just oblivious to it. We just don't get that level of detail. So very good. Shawnee Smith says JWST is about 70% unpacked. I didn't know it was that far along, but I'm still holding my breath. Any ETA of first picks? Yeah, I think we heard June is the earliest, and that's going to be a calibration image from what I understand, right?
That's what I've heard too. So we're looking at around 6 months before we start to get the first images back, and it's really just around testing, making sure everything's okay, correcting what they can correct, and and then once they get a go for everything, it's turned on for science.
Oh yeah. Oh man, we're gonna get some science off that thing.
Like I said, I can't wait. And look, the three of us have been talking about James Webb for a long time. The project was originally slated for what, $2-3 billion. I think that was its original budget, somewhere in that order, and it was well over 10 billion. So, and it was supposed to launch several years back. So, over budget, past time, everything else like that. But thankfully they stuck with it. They got the funding from Congress. It, was able to get off the ground literally and make its way into space. So I can't wait, man. I've been looking forward to this for quite some time. And like I said, I mean, Hubble has done some tremendous and amazing things. And what we're going to see with James Webb is just even greater than that.
Absolutely. And before Joe gets to what he got for the old Crimbus, what I'll show here is, hopefully I'll get the right one just real quickly. This is a website you all should favorite immediately. And I think it's jwst.nasa.gov. I mean, it couldn't be easier. James Webb Space Telescope, jwst.nasa.gov. Everything's an abbreviation there, or an acronym, basically. But what's really cool is look at that timeline on the bottom there. That is where the telescope is in relationship to where it's going, right? So you've got us and the moon here, and where it's going here, you can see that it's over half the distance. So you might be like, well, it's almost there. But if you look at the time, it's got twice as long to go. Because and I heard this analogy, and you guys might have heard it too. It's kind of like rolling a ball uphill to get it to stay right at the top of the hill.
That's it. Yeah, that's a good analogy, because one of the hardest things to do in space is make something stop once it's going, right? So that's what they've got to do. They had to launch this thing, get it to about 1 million miles out at that L2 Lagrange point, and get it to stop. And look, when we talk about a Lagrange point, it's not a tiny spot in space. It's actually fairly large where they calculate this thing. But again, you've got to get this thing to pretty much stop. And I like that analogy, rolling a ball uphill and getting it to stop at the top. That's pretty much what they're doing.
Yeah, and that's what I mean, and in my mind, that's not even good enough. I feel like, we're down here in Southeast Texas. You'd have to throw a baseball at Pikes Peak in Colorado and
Yeah,
get it to
yeah.
land in the male bathroom in stall 1. Like, it's
I
really,
mean, think
really
about it. You
hard.
got to overcome Earth's gravity just to get the thing up into, out of Earth's orbit. Uh, accelerate it far enough or fast enough to where it can get to that Lagrange 2 point, and then get it to stop. And then all while you're doing that, unfurl these sails, make sure that the mirrors unfold, the booms unpack. All these things have to go right. Just an engineering marvel. So fingers crossed that everything goes well, and that in 6 months' time they're doing the calibration tests and they're good to go.
Absolutely, man. And that's a picture of James Webb in its current state. Obviously, it's not a real picture. It's a simulation of what it actually would look like if you could fly next to it. But that's it. I mean, all they have to do, like we said earlier, is fold those 2 side mirrored sections out and start getting ready for some data collection. But again, don't set your alarms for June. It's going to be a long, long time, and
Yeah.
because they got a lot more work to do. That's for sure.
Absolutely.
So I'll put that away. We'll go back to that later, guys, I guess, right? And we'll talk about that later in the show. If people want.
One thing I was going to share, if it's good with you guys, let me go ahead and get this up here.
Yeah. I'll stop sharing this real quick. There we go.
All right.
Back to the faces.
Yeah. So you guys see that on the screen? If you take a look, right, we've got a pretty large spectrum of light, and what we see with our own human eyes is that tiny little sliver over there that says visible. And the Hubble Space Telescope is really attuned to catching visible light a little bit in the ultraviolet spectrum and a bit in the infrared. And when you take a look at the Spitzer Space Telescope, people would say, hey, well, we had Spitzer, that was an infrared telescope. Why do we need James Webb? Well, Spitzer looked at a different part of the spectrum, the infrared spectrum, and the gear that's on the Spitzer Space Telescope isn't quite nearly as sophisticated as what's in James. I mean, it's pretty sophisticated, don't get me wrong, but compared to the technology that they've packed onto James Webb, it's not quite the same. And then when you look at the actual near or mid infrared spectrum that the James Webb Space Telescope is going to look through, it's pretty incredible because, one of the things that we always joke around about is, hey, we look up at the night sky and we've got telescopes we can point out, look at galaxies. But if we're looking into the center of our galaxy, we really don't know what's on the other side, right? There's so much gas and dust and whatnot that is obscured. The visible light is obscured from, passing through all of that dust. So we can't really see these things with visible light. However, with infrared just kind of penetrates all of that stuff. So we can kind of peer through all that dust and gas and things like that, so to really find out what's happening. And if I can get this to change, okay,
There you go. Yeah.
so over on the left hand side, that's a very famous Hubble picture, the Pillars of Creation, right? I remember when I saw this for the first time, I was just speechless, like I am now, right? Pretty incredible photo, right? But take a look at it, there's a lot of dust and gas and things like that. So this area here is just bursting with new star formation, and we can't see it. So that's one of the things that just, we've got limitations with visible light and being able to see what's happening there. If you take a look at near infrared there in the middle, that's what the James Webb Space Telescope is going to be looking at. So you look at all of the star formation that's happening there. We're able to just kind of peer through and pierce that veil of dust and gas that we just can't do right now. And then if you look at the mid-infrared range where the Spitzer telescope is there on the right, that's kind of a simulation of, well, that's actually taken from there. But you could see the level of detail, the camera equipment and things like that. It's just not quite up to the same level of technical sophistication that you're getting out of James Webb. So it fits a niche that is going to allow us to peer further back than ever. See early galaxy formation, hopefully get a better understanding of how we got here, how our galaxies formed and how other galaxies formed. And so that's why I'm really excited about all the science we're going to get out of it.
Absolutely. How you doing, Bob? Good to see you.
Hey, Bob.
I think some of us know Bob. Maybe we've seen him on the observing fields. And Jeremy had an interesting comment here. Our speaker for Friday night's meeting, the Memphis Astronomical Society, by the way, has 28 hours of time reserved on JWST. That's a lot of hours.
That is a lot. Yeah.
Awesome.
And I wonder, are they taking requests, Jeremy?
I was
Because
going to say, can I get like 15 seconds?
Yeah. That much aperture, that's all I would need for this. Yeah.
Yeah, I was joking around. I saw a photo of the secondary mirror. The secondary mirror on the James Webb Space Telescope is a little over 29 inches. So the secondary is bigger than the primary on my telescope by a good 4 inches or so.
Mm-hmm. Yeah, that's a big secondary mirror, and it's plated in gold, right? I think it's also
I think it's beryllium plated and covered. Yeah, it's got a gold plating. Yep.
Yep. We had another question since we're on James Webb. Mark Jackson's like, how are they planning to make it stop? And the gravity of everything pulling on it, the Earth Moon system, the sun, everything else, they shot it with the exact right speed. It's almost like a perfect putt from 10,000 miles away. You've got a hole over there you got to put the golf ball into. And if you putt it just right, it's not speeding up all the way until it gets into the hole. It's going to speed up, slow down, and then just drop gently into the hole. So it's kind of
because you still have. Yeah, sorry to interrupt you there, Will. Yeah, you still kind of have the effects of gravity from the Earth. Once you get into the Lagrangian points, you've got gravitational influence from the sun and things like that. And that's what's special about those Lagrangian points is you've got this kind of areas where inertia is canceled out between these two large bodies, and you're able to get something to kind of come to a stop with a lot of precise calculation and launching and everything else like that. So
no, absolutely.
They must have some positioning thrusters too to get it dialed.
Oh, I'm sure they do. Yeah,
they do. Yeah, and that was they knew they could guarantee the mission for 10 years if ESA could get them within a certain threshold, and ESA got them past that threshold. So that's why they know they'll be able to, because those positioning thrusters will be used to orient the scope when they're, taking data and things like that. Right. They'll use some gyros in those thrusters and stuff like that.
Yeah.
Any idea how fast it can slew?
That I don't know. I'm not sure about that, but that's an interesting question, Bram.
Probably faster than my LX200.
Probably. Considering the size ratio.
Right.
Sure. Hopefully with more precision.
With more precision and it's quieter too.
Yeah.
I'd like to answer Hunter Ackerman's question. He asked, what is hydrogen alpha? And I have a little slide or a little image I want to share if I can figure out how to do that here.
At the bottom there should be a share, and then you just have to find the right
screen. Easiest with two monitors.
While you're doing that, Stephen Showalter got a PVS 14 for Christmas.
Nice.
Welcome to the club, brother.
Nice. I am jealous.
All right. Am I sharing?
Any pics of it, Steve?
Yeah, send us a picture if you can.
Send us a picture. We want to show it off.
Shawnee Smith says, can't wait to find out more about the atmosphere of exoplanets. Oh, yes. I mean, I'm all excited about nebula and galaxies, but that is an absolute yes, absolutely. Oh, man, it's going to be ridiculous.
Yeah, and infrared, you can actually start to make out those types of details. It's pretty incredible. So
I'm not bald, but I'll stick with you bald dudes.
Yeah.
That's okay.
We will stick together. Sometimes that's just skin on skin sticking right from the bald heads. But
all right. Can you see my screen share here?
Yes, we can.
We can.
All right. I found this website, AstroPix, obviously diving into that deep, dark rabbit hole we call astrophotography.
Of course.
But we're seeing a spectrum of light here. And, if you've ever taken a prism, a triangular prism, and split light, you'll see a rainbow, or you see rainbows, right? Rainbows are a prism effect where you see light split up into its constituent frequencies. And they've got a couple of important lines on the spectrum, the visible spectrum here, that astronomers are very interested in. So we have hydrogen beta here over in the blue region. Then we have oxygen 3. And then we have hydrogen alpha over here in the red area. And these are particular frequencies of light that are characteristic from, in the case of hydrogen alpha and hydrogen beta, burning hydrogen. And then on the O3, we have the presence of oxygen. So hydrogen alpha is a really nice way to look at the sun. So if you're just using like a Mylar filter and you look at the sun, you're only going to see sunspots, and the face of the sun's going to look kind of white. But if you have a hydrogen alpha filter, then you get to see it in more of an orange color, and you can tune it to see a lot of different phenomena on the sun. You can see, of course, you can see the sunspots, but you can see overall surface granulation. You can see prominences, which appear on the edge of the disk of the sun. And when the prominences are like magnetic field lines that lift off of the surface of the sun and carry material gases with it. And then if that energy becomes so great that it breaks the arc, then it throws material out into space and we have a flare. Also, when the sun's a sphere, obviously, and when we see this phenomenon on the edge of the sun from our perspective, we call it a prominence. But you can imagine that could be also more facing towards us, and so then we see it on the face of the sun, and when we see it there, we call it a filament. I hope that was helpful.
Oxygen 3, by the way, is my favorite oxygen, just to let y'all know.
Awesome.
Yeah, I like it better, 50% better than O2.
Yes, usually.
Sorry.
You guys are nuts.
Hunter says, what is SLU? SLU is just when you have your telescope pointed and you say, I'm on Jupiter, I want to slew to Saturn. So the telescope slews to Saturn. That's it. That's all SLU is.
Yeah, just the movement to a specified spot coordinate.
I guess it could also be an insult if you really wanted it to. I don't know how that works, but
SLOO is also SLOOH. That's completely different than SLEW, right?
Isn't it a body of water or something? Or
SLOO, the telescope, online telescope.
Yeah.
Is it spelled SL? It's like sloth.
SLOOH.
Like sloth.
Sloth. Robotic telescope service.
50% better, he said. There we go. Awesome. So yeah, I mean, that's Webb is really gonna revolutionize so much stuff, and we're gonna do more live streams on that. I can guarantee you that, especially when first few data sets comes through. We're gonna do a live stream just so we can feel like we're a part of that, even though we're not at all. But we'll definitely do that. So
we're along for the ride. Come on.
Yeah. No, we are.
That's it.
And we don't have to freeze our tails off at L2. Of course, on one side of the scope, I think it said it's 135 degrees right now on the hot side. Right. On the cold side, it's negative 325 degrees Fahrenheit.
Yeah. They've got to keep the instrumentation and the optics at such cold temperatures. That's the reason why you have all of the sails and everything else, really to block a lot of the light that's coming from the sun, and make sure that all of the instruments are at the proper temperature in order for them to operate.
That's right. Yep.
Will, do you love your nebulas?
I do.
Nebulae?
I do. I love nebulas.
Nebulas.
Planetary nebulas are my favorite planetary nebulas. So, Joe, did you get something for?
I did. Yes, I'm actually reaching for it now. So, not quite the James Webb Space Telescope.
No,
but there it is, right? And people are like, okay, well, what is that? It's a telescope. It is a telescope. And Bram actually has one of these himself.
Love it.
This is a finder scope. So if you have a telescope, you can't just point it, unless you've got something fancy like the James Webb Space Telescope. I guess you don't need a Telrad on that, right? But we use these smaller telescopes or finder scopes when aligned with the telescope to make sure that we're pointing the telescope in the right direction. So these usually have smaller optics than the main telescopes that we use. A much larger field of view. There you go. You can kind of see in there.
I can see your ceiling fan, actually.
Yeah, you can see the ceiling fan. Yeah, you see that? There you go.
It's working. It's working.
We've got a good optical light path.
We do.
But the thing is, you get a much larger field of view with these finder scopes than you do with your main telescopes. And so these get you to where you need to be. And then from there, you can switch from looking at the finder scope into the telescope eyepiece itself. And hopefully you're spot on to whatever object you're looking at. So I saw Bram had one of these on his telescopes, his 22, right, Bram, or
20.
20 inch telescope, and he's got his Telrad on top of it. And I was like, that's a nice setup right there. This is probably the biggest finder scope that I've seen. It's an 80 millimeter, which is, ironically, this 80 millimeter finder scope is bigger than the first telescope my parents ever got me. I got a 60 millimeter refractor. So this would have blown away what I started off with. But this is the finder scope for my new telescope. So I've got to get it mounted. And
it looks like you've got, is it an illuminated reticle on there?
It is. So these are called RACI or RACI finder scopes. So they're right angle corrected image, RACI. And so what you're seeing when you look at the finder scope is kind of a representation of the sky as you would see it with the naked eye, right? So it's not inverted, it's not flipped, it's not anything like that. So, and it is illuminated. So, when I turn this on, there are some illuminated crosshairs that show up there, so I can get some better or more precise alignment on whatever it is that I'm looking at. So, yeah. So this is my holiday gift to myself. And, I was my own Santa for this, but it's still a holiday gift for me. So
wait, what do you mean?
There
ain't no Santa?
Spoiler alert.
No. So Joe, that's going on your 25, I guess, right?
That is going on the 25. Yeah. Haven't put it on yet. All I've got is a Telrad, but the three of us were out at the El Dorado Star Party, not this past year, but the year before, or excuse me, in May, was it? Yeah, we went to, it wasn't the El Dorado. We went to the X-Bar Ranch, which is where the El Dorado Star Party goes on. But because they had canceled the Texas Star Party, we just decided, hey, let's go out to West Texas anyway. And I didn't have all of the gear working on my telescope, so I couldn't use the fancy and go-to and things like that. And all I had was my Telrad. So trying to find things in a large telescope where you've got to climb on a ladder with just the Telrad's a little tough. So it was after that Bram convinced me, you got to get it. Even though Will was saying, nah, I don't use one. I've got one, I don't use it. So, this can get a little bit of a, almost like a little religious war here. But 25 inches, 8 feet off the ground. I was like, I've got to have something.
And Telrad, the other thing that Joe is mentioning there is a crucial step, even for those of us that have small scopes. A Telrad can be crucial, especially if you just want to go out and look at the moon or something bright. That's easy to find. Once you get everything aligned, you just literally put those red rings on the sky and point your telescope to it. And there is a Telrad right there. So let me bring you up. There we go.
Yeah, there you go. So this is a Telrad, and unlike the finder scopes, and actually, let me pull up another finder scope. So, when you become an astronomy nerd, you end up with a lot of just spare gear laying around the garage and the house and whatnot.
Very true.
This is a small, pretty standard finder scope that you get on a lot of telescopes. This came from a Celestron C8, an 8-inch Schmidt-Cassegrain telescope. But this is if you can see it there, it says 6x30. Do you guys see that? So
almost
6x30.
There you go.
6x30 LER finder. Okay. And what that means, the 6 indicates the magnification, so 6x magnification, and the 30 is the size of that lens right there, 30 millimeters, right? Obviously, the bigger that number, the bigger the lens, the more light you're going to gather. So that's 30, and this here is 80 millimeters, right? So pretty significant difference there. You see all kinds of different finder scopes, sizes in between and whatnot. But to Will's point, the Telrad is not magnified. So it's not 6x, it's not 2x, it's not 10x, it's basically 1x. So what you see when you look in here are a series of concentric circles. So let me see if
there you go.
See that? There you go. Okay, so it's projected onto this little piece of plastic. And if you point it here, there we go. You can kind of see where that comes from. But then it illuminates this up here, and you're able to get this aligned to whatever you're going to look at, and you have those circles. And Will and Bram, I believe it's 1/2 degree, 2 degrees, and 4 degrees. Those
That is
three
correct.
rings.
Yep.
Yep.
And so if you're doing some star hopping and things like that, you can use those rings to help guide you to whatever it is that you're wanting to go to. So if a nebula or a cluster or galaxy is 1/2 degree from a bright star, you can find that bright star, put it right in the middle, and then move your telescope or slew it about 1/2 degree, or basically that inner circle's width out, and find the object you're looking for.
Yep. And they do have all that printed on there as well, which is a handy little thing to have. But like I said, you can have a small telescope, even one of the cheaper ones, and a $40, I think they go for about $40 still to this day.
Yeah.
Worth every penny. I think I have like 7 of these things.
Yes.
Because I'm always like, where are my telrads? And I always have, they're in just different spaces. But
yeah, the cool thing is once you get it mounted, especially if you're using the mounting system that they provide with, it's got some feet here down on the bottom. You basically use these 3 buttons on the back to align it, right? And those 3 buttons, or those knobs, they're actually turn knobs. They'll move that ring out into different areas. So you want to do this alignment typically during the day, or maybe when it's a little darker where you can see the rings and whatnot. Trying to do it at night's a little bit tough, especially in pitch black. But yeah, once you get that aligned, it's pretty rock solid. I don't think I've had to change the alignment of my telrad in quite some time. Whereas whenever you put one of these finder scopes on, you actually have to go through the process, usually during day, to make sure that it's aligned with the optical line for your telescope itself.
absolutely. Yeah. We did have a couple of questions. So before we get to Bram's Christmas holiday cheer, I guess, or what was left of it anyways, Shawnee says, y'all get some good pics of our buddy Leonard. I got some pictures, but good they were not. There were nights where it was in the eastern sky, just foggy, moist, and nasty outside.
Moist.
Yeah, our favorite catchword. But then when it got over to the west side, back over, which is, I could point any direction and y'all would believe me. That actually is. But when it got over to the west side of the sky, it was bright, but it was setting super fast after the sun. So I got a couple of cell phone pictures, but I don't know. Did you guys get anything or?
I didn't get anything at all. And to be honest with you, we were on vacation, so I didn't get a chance to really look at it when it was in the best position to be seen. So I didn't get any pictures. I didn't even get a chance to look at it visually.
Oh, wow.
Same, bro.
Same, yeah. I saw
yeah,
it a few times in binoculars, and guys, y'all didn't miss much. I can tell y'all that. It was, I've seen dozens of comments at this point.
Yeah.
And it was one of the more lackluster comments that I've ever seen. In all honesty, except for like maybe the ones that were only telescopic that you never heard about in the mainstream media.
Right.
Those were maybe a little more lackluster. This one at least was almost naked eye. Yeah, it was just kind of one of those duds, I guess. But you never know what these comments are. That's why they report on them, because this thing could become the next Hale Bop or Hyakutake. You never know.
It's been a long time since we've had something like Hale Bop. So.
Yeah, absolutely.
Something that lingers in the night sky, even in suburban skies, that's super bright and hanging up there for months at a time. We're due.
Absolutely, we are due. Jeremy says, saw Leonard for the first time Monday night, which was a couple of days ago. So this Monday, after the 1-day-old crescent moon. That's probably a beautiful sight to see right there.
Yeah, absolutely.
Awesome.
Then Mark had a question.
Yeah, I saw that. So Mark says, this might be a dumb question, but I've never really used scopes before in much detail.
Ooh, I'll take it.
Okay, go ahead.
To continue his question, do the photos we take of the sky look different to what we see if we were to just look through the lens? Generally speaking, yes. So when we look through a telescope, aperture is king. The bigger the aperture, the more light we can gather, the more detail we can see. But astrophotography has the ability to trump that every time, because they can basically track the object, if they're doing it right, suck in a lot of light, collect a lot of photons, integrate that together, and pull out amazing detail. But those guys, they just run their equipment all night, taking these long exposures, and then they spend hours laboring away post-processing to produce these wonderful images. They probably get to drink a lot more than we visual observers do, though. When
They
we're
definitely do, and
They do.
They end up coming and hanging out at our very scopes, actually.
They do. And they
Yeah.
actually sleep a lot more than we do, too.
Yeah.
Yeah.
Some of them do bring some amazing white Russians around, though. Yeah. I'm not going to mention any names, but yeah.
No
Well,
name.
I need to know who, so please tell me so I can look for them next time.
Yeah.
If you see John
Right,
Talbot on
offline.
the field, get with him. He'll always have
Gotcha.
something
Okay.
good.
Nice.
There's a few
Nice.
names I can think of here.
The guy I'm thinking of, his name's not coming to me right away, but he also used to be he used to run a reptile shop here in Houston.
Reptile.
Yeah.
Reptile.
Yeah, we were at Okie-Tex one year, and there was a little baby rattlesnake in the grass, and some guys wanted to kill it. He's like, no, don't kill it. He goes to his trailer. He comes back. He's got one of those reptile hooks, and he just scooped it up and carried it off somewhere, gave it a toss, and
wow,
there we go. Yeah,
and on it still probably lives.
Yeah.
Hey, I got a question. I hope this guy's still here. At 9:06, somebody named Platon Leontev posted something very cryptic. Capital V, little U, capital M.
That was probably
what is
probably
that?
a bot.
Oh, really?
Yeah.
Hey, Platon, if you're still there, and you're not a bot, give us another post. Let us know what that is. I'd like to revisit that.
I think they were trying to type an ORG maybe. So I don't know.
Maybe.
You never know.
If that's the case, that's the worst bot ever.
Yeah. Well, there's some bad bots out there, but that's how it goes.
And Steve Showalter, he got some night vision gear for Christmas.
Yeah.
Pretty sweet. Yeah. That's what I want next, honestly.
Yeah. And that's the only way to go is the PVS 14 right there.
Okay, so back to that question about astrophotography versus what you see in the eyepiece. That little device right there multiplies your aperture by an order of magnitude.
Yeah.
Turns your by 2.
Yeah. So if you have a 20-inch telescope, it's pretty much a 40 at that point.
Yeah, it's amazing.
Yeah.
Totally amazing. Not for every type of object that we view, but for nebulas, a lot of nebulas, they just look super.
We've looked at some galaxies that looked really good. I remember, Will, we were looking at the Sombrero Galaxy in the 25 with that, and it just popped. And then we looked at other galaxies, and we're like, kind of looks better without it, right? Just using the eyepiece. So, but yeah, for nebula, it's incredible. Planets, you don't need it, right? With planets, they're so bright that you don't really get any benefit. You probably blow your eyes out.
Yeah, and you would probably, these are auto gated. If you do ever buy one of these, make sure it's auto gated, which means that it's too much photons come in, it will duck down the amount of accepting of the photons that it will do. So, and they build that in for the military. So if somebody shines a bright light at the people looking through these, it won't blind them or ruin the unit. Because I know back in the olden days, these units could get ruined by too much bright light. So
lasers and things like that, huh?
Yeah, just people shining bright lights at I guess people who are using those, and they're a useful tool for a lot of things, but astronomy turns out they're pretty great for.
Yeah. So going back to Mark's question when he asked if what we look at through the telescope matches the photos, and Bram did a great job of answering that. But I wanted to point out there's a great book called Turn Left at Orion. And in that book, guy, I can't pronounce his last name. He's the Vatican astronomer who wrote this book, but he actually has some Consalmo. Okay. He does a great job of kind of sketching what to expect when you look at these objects in a standard amateur telescope. So again, it's not what you see when you're looking at Astronomy Magazine or Sky and Telescope or anything else like that. we just can't collect that many photons in our eyes and you know, continue to process it that way. So, but when you know what you're looking at, and you know, Will, Bram, you and I have talked about this. When you see a quasar that's, you know, 1.5 billion light years away or something like that, and you're looking at this faint fuzzy object and you see it, and you're just the thought that, hey, this light that's hitting my eye now traveled across the universe for 1.5 billion years, and I'm looking at it now. It doesn't look. I don't need all the fancy colors and everything else like that. When you realize what it is that you're looking at, it's pretty special.
Absolutely. Absolutely.
So, what's the oldest object that you guys can recall having seen? You don't even have to remember what the object is, because I've got one in mind. I don't remember what it was at this point. I just remember the age of it. So, how far back have you guys looked?
Larry Mitchell showed me a quasar at 16 billion light years, which is older than the universe is far away, right? But because of what's called cosmic moving distance or co-moving distance, that's how far that quasar is.
That's almost believable.
And it was stellar. It was a point of light.
A photon.
But, one photon, but it was it's a core of a galaxy. It's an AGN, an active galactic nuclei.
Yeah.
And that was wild.
Yeah, that's nuts. I remember looking at something that was 11 billion.
8 billion for me. So you guys both have me beat. But even then, 8 billion, I was just like, I can't believe I'm looking at something that far away, right?
Mm-hmm. Yeah.
Absolutely crazy. Didn't get a chance to look through Larry Mitchell's telescope. Larry's got the 36-inch giant cannon, the howitzer. If you're ever at Texas Star Party, you'll see him on the upper field. But that's crazy.
Yeah, you gotta if you ever get a chance to swing by Larry Mitchell's scope, you have to. It's not even an option, and he's very cool. He'll show you whatever they're looking at the time. And you got to climb a long ladder though. I think it's a 16-foot orchard ladder,
something like that. Yeah.
And you're at the top.
Yes. You're up there. You're on unstable ground. Sometimes it's wobbling, and it's a lot of fun when you're doing that in pitch black darkness.
Yeah, absolutely. Yeah, and I mean it's, you know, sometimes like so one of the most interesting things Larry showed me in his 36 was the jet in M87.
Oh yeah.
And so there's a galaxy called Messier 87. I think that's the number, right? Yeah, it's something like that.
M87. Yep.
And it's a galaxy. And out of the core of the galaxy, out of the black hole, is this jet, a relativistic jet, meaning that the material is coming out at close to the speed of light, not at the speed of light, but at a significant percentage of the speed of light. And you can see that jet. You can see it. It looks like a little peanut, just like coming out of the galaxy. You can't see the whole thing because it goes on for billions of light years or millions of whatever. It's a huge thing. There it is. And you can see that visually.
Yeah.
And
so is that coming out of a black hole?
It is.
Yes.
Yep.
Yes. So
out of
the way.
Hole. Yeah.
Well, and this is a super massive black hole, right? So if you all remember a couple of years ago, they had that first image of a black hole, and I'm using air quotes there, but that image that they got was from the black hole in M87, because even though it's quite some distance from us, it's so big and so massive that it was the best target, best candidate for potentially capturing that image. So, but you can see here, right? This is kind of the core of the galaxy there. In this area that's extending out to the right, that is that jet that Will was talking about. So we happen to be looking not quite down the barrel of that gun, right, but off to the side just a little bit. It's shooting out this way, and chances are it's there's another jet on the other side shooting out that way as well.
Yeah, and I guess that other one's just obscured to where we can't see it, but there's always coming out of the North Pole and the South Pole of black hole.
Yeah.
Same thing with stars. Like you'll see like fledgling stars or like brand new stars that are just kind of turning on. The material they can't absorb, they kind of falls toward the star, gets swirled out through the tops and the bottom.
Yeah.
Kind of as it's going in like that. If you can watch my hand motions here, I'm going to make myself disappear next, but no. You can kind of see that, it's harder for the angular momentum of this stuff falling in to come out of the sides. So it kind of wraps around the top and comes out and shoots straight up or straight down. Up or down in space really doesn't mean anything, but yeah.
relative to the plane of orbit, I
relativistic
guess,
up and down.
of rotation. Yeah, absolutely.
We did have a question from Jeremy. Oh, sorry. There we go. Any good recommendations on a good mirrorless DSLR for beginner astrophotographer? The only one I can recommend is the only one I own, because I just got into mirrorless DSLRs probably in 2017. I got a Sony A7S Mark II, and I would never buy anything else other than that. The Mark II on the Sonys is just phenomenal. Great. It's the most sensitive chip I've ever owned, period. And it can do just insane things. It does 500,000 ISO or 400,000 if you want to, get nitpicky with it. But it's crazy. So it does video, it does 4K video, but it also does all this other stuff. I will say the problem with mirrorless DSLRs is they don't have the mirror. And you'd be surprised at how awesome that mirror is when you're changing lenses or you're taking the lens off to put it on a telescope. You are then just kind of letting stuff collect on your open sensor. And it has good and bad things going for it. So there's, sometimes you get dust motes on your sensor, so you have to be able to clean that, which is not fun. It's never fun to like touch your sensor in your camera.
Right.
So
touch your sensor.
Yeah, can I touch it? Just don't get one of those and imagine that it's gonna stay clean forever. Okay, so but would I buy another Sony A7S Mark II? Yes, I would. I don't know if you guys have any
endorsement of the mirror purely as a dust protecting device, right?
Yeah, I mean that's all I could really. Yeah, but I mean the mirrored DSLRs do a great job on all levels of astrophotography as well.
Yeah.
And a DSLR is a great way to go about it. I think though now, and maybe somebody out there can correct me, I think DSLRs are going the way of the dinosaurs, because there's companies like ZWO and some others out there that make cameras that are far cheaper or even comparable to a DSLR that are meant for astrophotography that can do way better work than a DSLR. So, and with less effort maybe too.
Yeah, absolutely. Less moving pieces and parts. I mean, they're devices designed for astrophotography, typically. So, fewer functions means fewer, bells and gadgets and gizmos and things like that, fewer things to go wrong. But I don't have a recommendation myself. I was going to mention the camera that you had. I've just seen incredible things out of those Sonys, and I'm not much of a photographer, so I don't really, go out there. Every time we're at a star party, Will's got about 20 cameras out and doing all kinds of things with them. So I trust his opinion. There we go.
Covering all the angles.
Yeah, exactly. So, and Bram, I think you were going to show something on the screen.
Oh yeah. What do we got here?
Is it sharing or not?
Yep,
there we go.
Okay. I guess what I'm looking at on my phone is lagging behind because I don't see it there. But this is maybe a little late to the party. I just wanted to show, Joe showed his finder scope. Oh yeah, there it is. Joe showed his new finder scope, and here you can see how I've mounted my Telrad on top of the finder scope. And it's sitting right above the eyepiece. This happens to be my 12-inch Orion grab-and-go telescope. And I use it pretty much the same way on my 20. But it's really nice setup because I can use any of these instruments pretty much from the same standing position or ladder position wherever I am. I can lean over and peek through the Telrad pretty easily, or look down the eyepiece of the finder and then switch over to the main eyepiece. So it's a great way to star hop.
It's a nice, convenient way to have it set up as well, Bram, because, as Will mentioned earlier, if you're on the top of a 16-foot ladder, the last thing you want to do is be leaning in and trying to get at different angles to get through the finder scope, the Telrad, and the eyepiece itself. So having them all together like that's a nice setup.
Right.
Yeah, because Bram's 20-inch Stargate, you're on a ladder, but you may only be on the bottom rung.
Right.
but yeah, if you got to start getting back off and backing up and doing all kinds of weird things like that, sometimes that can, like Joe said, it can just be added fluff that you don't need to do. And there's Bram with that 20-inch Stargate right there. Look at that.
Yeah.
Sexy.
It's naked right now. I don't have the finders sitting in there in the shoe, nor do I have the shroud on there, but you get an idea of the scale of this thing.
Yeah. And for those of y'all that might be wondering, it is a mostly open telescope, meaning it's a truss tube telescope. And you can see there he has a shroud on, which kind of helps, contain the light a little bit. It just helps buffer out any, somebody next to you might have a red flashlight they're walking around with. You don't want to see that in your image while you're looking, right? So this thing can kind of help that. It also, I think, helps for contrast too, right, Bram?
Yes, sir.
Is that was that taken at the outreach event we did at Rice University?
Yes.
Okay. I remember those beanbag chairs. The things we remember.
Let's see.
But to answer Hunter's question from earlier, this scope, if y'all remember his question from earlier.
Yep.
You can definitely see your neighbors.
And I think with that, your neighbors are going to see you too. So
yeah, they might see themselves in the mirror and be like, "Why am I seeing myself over there?" But you can't see your vampire neighbors with these scopes.
No, you can't.
Strictly because they use mirrors.
That's
so
it.
Don't look
even
at
with the Schmidt design. You can only get the photons reflecting off of that vampire for so far.
Yeah. Yep. Once it hits the mirror, it definitely ruins it.
Yeah. And we got a question from Mahesh. Said, given folks may have bought telescopes and some may be beginners or first time step up to a better telescope, how about doing a live stream of a field session to show how to set up and do the observations? That's a great suggestion, Mahesh. Thanks for that. And, Will and Bram and I talked about that before we started. And I think we're going to probably set something up soon to do that. Maybe have different types of telescopes, like a Schmidt, a Dobsonian, a refractor, things like that. So yeah, absolutely.
Yeah. And I've done similar things on TikTok, but never on these platforms. Each social media platform kind of requires its own rules of usage, I guess. For something like this, it's kind of harder to do that, that kind of style. But yeah, it's always helpful to kind of see somebody. The problem is there's so many options and optical designs out there that it becomes like it's hard to like figure out, what direction to go with that, because so many people have this style or this style. And if you focus on that style, you're not helping these people. Right. So what we're hoping to do on streams like this and ones in the future is have y'all come to us with those questions if y'all do.
Yep.
So your specific setup, and then we can get real nitty gritty on your specific setup. Like Bram's scope there. Let's say Bram was having an issue. He could show us the setup and we could say, well, you just didn't put this value in on the hand controller correctly or something. Whatever the simple or complicated answer is, that'll help you. So, yeah.
Yeah, shameless plug. We did something similar with the Houston Astronomical Society several months back. We had our friend Tim Pellerin, who is with Lancy and Sky. They're a supplier of astronomy and bird watching equipment. They also have microscopes here in the Houston area. But he and I did a live stream for the members of the Houston Astronomical Society where we set up various types of telescopes and went through. Again, you couldn't do every possible configuration out there, but some of the more common ones. So if you go to, again, shameless plug, the YouTube channel for the Houston Astronomical Society, I believe you're going to be able to find that video out there. So go give that a view, and we'll work on putting something together on the back end here.
Yep. And send us those questions if y'all have them.
Kenny said, I got to look through those.
Yeah, I think he was talking about the PVS 14.
The PVS 14? Okay, not sure. Let us know for sure, Kenny.
Yeah.
You're still out there, Kenny. Added the exclamation mark for emphasis.
Yeah, it probably got left behind, so it trailed in.
Yeah. And Mark, I'm just going to say, don't do it.
Yeah.
Don't do it.
It can definitely
I'm joking.
be
So we joke around, right? It is a almost like a religious war between astronomers. You've got the visual camp and the astrophotography camp. There exists this new niche that's growing kind of in between them, the electronically assisted astronomy niche, which is not really true astrophotography and it's not really true visual observing, but that may be a good place to start. But no, I'm just joking. If that's something that you're interested in doing, by all means, take it up. I just don't have the patience for astrophotography.
Yeah, and like Bram and Joe have said, it's a lot of work.
It is.
Half of the battle is you waiting for clear nights, going out and setting up your gear and getting good data. That alone is hard. Okay.
Yeah.
And then once you get your good data, you have to come home or go into a cave somewhere and get on a computer, a PC, so whatever you're using with the proper software and tease the details out of that data. Because when you get the data, it's going to be dark and you're going to be like, I didn't get good stuff. And this is what everybody told me to do. I followed it to the letter. You're going to get home with this data that you think is going to be garbage data. And you go through the rest of the process. And then all of a sudden you have an image and a good one, and it's all about practice and getting the right night. You can go out on a bad night and get decent data, come home and try to start editing it, and you're like, well, what happened? Well, maybe the sky wasn't as transparent as you thought. So like Joe said, don't do it because it's super frustrating. I've always looked at astrophotography as something to do while I'm visually looking at the universe.
There you go.
So when I'm waiting for my little camera over there to get its 1,000 images, because like Joe said, what are you going to do while you're going to walk around and hang out with all the visual astronomers is what you're going to do while your astrophotography rig is over here going off, doing its thing. Right. And I mean, that's just the nature of the game. So make friends, at these star parties or at these events or whatever, if you're going to do astrophotography, because you're going to need friends. Astrophotography is very boring by yourself.
Absolutely. And you can always spot the astrophotographers at star parties because they're always walking around with a mug. Yep. Right? They've got coffee or tea or something, and the elbows out to the side, and they're just walking around. Hey, what are you looking at there in your telescope?
Oh, nothing. Just looking at faint galaxies. What are you doing? Oh, I got my astrophotography rig over there going on.
Yeah, just taking my darks right now. So
just doing some calibration frames.
Some calibration. Yeah, exactly. So that's it. That's the telltale sign of an astrophotographer is the arm cocked out like that with a mug in it.
But like if you want coffee, if you need a beverage of some type out on the field, they probably got you. You can trade, you can barter photons for drinks.
Absolutely.
I've done that.
And look, if you are just that much of a coffee connoisseur, which we've got one right here, right? And you're just looking to consume coffee late at night with a bunch of other people, astrophotography might be that gateway drug for you. So.
Yeah, absolutely. And like you said, it's an addicting thing, astrophotography, because it just takes that one session for you to be like, well, I think I'm getting good data, so we'll see.
Yeah.
And then you get home, or you get the next day, you wake up and you start processing it, and you get that image, and that bug crawls directly under your skin, and it doesn't usually come out until your stuff starts breaking, which is a different bug altogether. But
it's kind of like golf, right? It's
like
once you hit that nice, that first shot off the tee that's just, straight and down the fairway, that's when you get hooked. And I think the same way with astrophotography. Well, once you take that first image, you're like, I got it, or I'm so close, I'm good at this. That's when you get sucked in.
Yeah, I remember I found the pictures from when I was a youngster in 1996. My mom gave me an SLR camera, a 35 millimeter SLR camera, because I knew, I was reading Sky and Telescope, that if you held the shutter open for a long time, you could get nighttime stars and stuff. And I had these squiggly pictures of star trails, but I remember getting those back 3 days later from the Kmart photo development place. I had to go turn my film in.
Back when you had to turn in film,
develop it. Yeah, and then I got the images back, and they were garbage, absolute garbage. And I'm like, this is the coolest thing I've ever done in my life. I mean, that was like kind of the beginning of that bug. But you're right, Joe. Like, I remember my first digital image It was through a friend's scope on the Orion Nebula, and it was blurry and it was garbage, but there was color and there was detail. And I knew what I was looking at, even though it was blurry. And I mean, I was like jumping around. I was like, yeah, and I mean, I'm still chasing that rush because I get an image back now and I'm like, hey, so.
Well, one of the cool things, and I'll show this here. Again, this isn't a shameless plug, but there's a lot of really cool astrophotography you can do just with an iPhone.
Oh,
right? Especially if you're
yeah.
doing lunar astrophotography, right? So bear with me a second while I pull this up. But Will, you and I have done this. I know Bram has done this, where we just put, and this is from my Facebook page, an image that I got with an iPhone. And this was just putting the iPhone up to the camera up to the eyepiece and taking an image. And that's the beauty of lunar astrophotography, is because the moon's so bright, we can get good focus on it really easily. You don't need a lot of fancy equipment to get images kind of like this. So I thought that was absolutely fantastic. And so the limit of my astrophotography is usually images of the moon like this.
Yeah. And like you said, Joe, this is a great way to get kind of the bug, because especially now, if they would have had cell phones back when I was doing my first imaging,
right.
But yeah, this afocal photography or projection photography is super easy. I mean, really all you need is a telescope that you would normally look through, right? With your eyeball. And then what Joe did there was took his cell phone and put it up to where you normally put your eyeball, and you start taking pictures, and there you go. But yeah, Joe's right. The moon, what do you got? The moon, you got Jupiter, maybe Saturn. I mean,
maybe Saturn. And this is
that's
just another image. Yeah, with the iPhone, exactly. So this is the just to kind of give you a view. You can tell that I'm looking down the barrel of an eyepiece here and trying to get this image. So this is just a horrible image, but this is really just an indication of there's not a lot of fancy equipment. iPhone up to the eyepiece and didn't quite get the right angle, and this is that image that I got there, right?
Yep. And you can see the barrel. You can see the internal reflection from the light of the eyepiece there.
Yep.
And you can also see, but there's a lot of science you can do with this too. Like you can see Earth shine.
Yep, you absolutely can. Right here. There. So you can see the curvature of the moon right there. And
that's,
the Earth
that's sunlight bouncing off Earth and hitting the dark side of the moon, because that is the dark side of the moon, y'all. Don't let anybody ever tell you that the dark side of the moon can't be seen. Yeah, because that's the dark side of the moon right there. Yeah.
And then the other thing I was going to show, Will, you and I, a couple of years ago at the El Dorado Star Party, worked on this image here.
Yeah.
So this was one that, Mars was close to opposition, and I had my telescope. Will had his ZWO camera, and we just said, hey, let's give this a shot. And one of our good friends, Bill Flanagan, was out there, and Bill's a pretty accomplished astrophotographer in his own right.
Absolutely.
Gave us some tips and pointers and told us what to do, what to capture, what software to use. And, we gave it a go, and this was the result of that. So I was pretty impressed with what we were able to do here. And then I just said, okay, it's kind of like that first hit. I don't want to go beyond this and really get sucked into astrophotography. Yeah, the first one's free. So this was my first hit there, and I'm done.
And what was cool is, like, Joe had the entire optical train set up. I didn't have that set up, but I had the camera, the computer, and all that. It was a real windy night, so we had to fight the wind. We had some focus issues, but we finally nailed that in. And while Joe kind of collected, because what Joe did was take video through the camera and the telescope and everything. He took video of the of Mars, and the video looks like absolute garbage. It's fuzzy, it's blurry. Mars is doing this sort of thing. It's just like blah, 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 blah. But then Bill Flanagan swooped in and was like, "Oh yeah, you just look what the greatest dollar again. This is actually really good." And we're like, "Are you
sure?"
And no, look, just pull that slider out, but you want to do that only if you had this option clicked. And then I came back in like 5 minutes later into Joe's little hut, and this is the image I saw, and I was like, what? Like, dude.
And the amazing thing is we didn't really capture a ton of data, right? It was a pretty limited data set, just given the amount of space that we had on that particular computer. But, we put it together, and out of that limited amount of data, we got this. Now, one of the artifacts I couldn't quite figure out is why we couldn't get this polar ice cap to come out white. And that was something that we just could never figure out. The rest of it looked like what we would expect to see here. But yeah, I was pretty happy with this. You can see the date there, October 17th, 2020. So a little over a year and 3 months ago. Yeah, a little, year and some change. But I mean, that was my first real attempt at astrophotography that didn't include putting the iPhone up to the eyepiece and trying to snap a picture of the moon. So I was pretty happy with it.
And with Bill's tutelage, man, you nailed it. You hit it out of the park, I think. I mean, this is even the area where Jezero Crater is. I think Jezero is just to the right of that little peninsula that kind of comes down in the darker material. I think it's just on the right-hand side of that. So this is where Curiosity, Perseverance. Sorry.
Perseverance, yep.
I'm like 2 rovers behind, sorry. That's where Perseverance is right now, drilling into Mars and stuff. So it's just an amazing thing that you can do. And again, this was video that Joe was running through this, not a really expensive camera, just a mid-range camera, maybe like $200 or $300.
Yeah.
For some people that might be more expensive, but for some they might be like, well, I can afford that. I spent that on shoes or something.
There are people that spend 30 times that on some of their cameras.
I know, yeah. And this is the kind of data. Now, the scope that Joe had to do this was no $200 or $300 scope. It's a very precise instrument. So there's that. So don't think you can just go out and buy this camera and get shots like this. But yeah, this is definitely something that's doable.
The other thing that we did is you'll notice there at the top it says Celestron 3X Barlow. So if you're not familiar with what a Barlow is, I'm holding up a Barlow here. This is a Teleview 2.5X Barlow. And what this does is basically extend the focal length of your optical train so that what you would normally see with the eyepiece or capture with the camera is magnified that much more. You're getting that much more data on the sensor there. So if we didn't have a Barlow attached to this, that image of Mars would have been much, much smaller than what you see there.
What, 3 times smaller, I guess, right?
3 times smaller, exactly.
Like Grinch's heart.
Yeah, it'd be, exactly. You'd probably get, something the width of this bright area here for Mars, maybe even smaller than that. Yeah.
Yeah.
So that's something that you often see with, I was just going to say, that's something you see a lot with planetary astrophotography. You'll normally see the use of Barlows. 2X obviously is fairly standard. 3X is very common. And sometimes even 4 or 5, just depending on how good the seeing is and what kind of conditions you have for that night.
Yeah. I almost always use a 2-inch or a 2-inch 2X Barlow in my visual setup.
Yeah.
Because if you have one of those, it essentially doubles the amount of eyepieces you have.
Yeah.
So it's a useful tool.
And this is 1.25 inches. You can kind of see it there, really narrow. So I can only use this with 1.25 inch eyepieces. I can't use it with the 2-inch eyepieces. Usually, generally speaking, your better eyepieces are 2-inch eyepieces. Some of them can get pretty big. So this is a 21 millimeter Teleview Ethos, really nice eyepiece here, but it's just not going to fit in there. So to use a Barlow with an eyepiece like this, you do have to have a 2-inch Barlow, like Will said.
Yeah. And invest in a good one because these eyepieces will last literally forever. They're something that you will be selling in an estate sale for yourself. See what I'm saying? So, optics don't really go bad. Glass doesn't really go bad. The metal and the other stuff can corrode over time, but the glass in these telescopes is going to last forever, literally, trillions of years. So unless something explodes them or whatever.
They're made of star stuff.
Yeah, no, just experience. I mean, glass lasts forever. And glass doesn't run. Whatever you've heard about castle windows is all a myth. That is an absolute lie. But glass does last forever and it does hold its form forever unless you heat it up too high. So spend the money. Those eyepieces Joe held up are not cheap, but
they're not.
It's like wanting to watch the new Matrix movie on like a 720p TV or a 4K LED TV. You know, like if you have
I'd
the
say
money, go ahead and do it.
why buy a Ferrari and put bicycle tires on it?
There you go.
Yeah.
You know, you want to make sure that you've got the right tires, the right equipment, everything else to go with it. And to me, look, if you're doing it right, your eyepieces are probably going to cost more than a lot of the telescopes that you're using them on. So I see that quite commonly. I was joking around with somebody earlier today, with this case that I've got with these eyepieces. Sometimes you feel like you've got to have them, the handcuffs attached to your wrist while you're walking out to the field. You can have a few $1,000s worth of eyepieces in those cases. So, but definitely worth the investment, because again, you can use these in any telescope. So
Yeah.
I can take this and go look through Bram's telescope with it. I can take it, go look through Will's telescope, and what I see is different because of the different characteristics that they have in their telescope. So
Absolutely. And you can sell them if it turns out you don't like it or it doesn't work for
yes,
you. Or you can buy, like, say Joe is just tired of that ethos and he wants to give it to Will. You know, that can happen. Yeah, just hand it to me
Here
and
you go,
I'll
Will.
I'll just take it. Thank you. That'd be so cool if I had a shelf right here with one on there and we could next time
Exactly.
we'll plan that. Next time we'll plan that. Let me go ahead and take some admin action here. There we go.
There you go.
See ya.
Hey, Corin, how are you?
Good to see you,
morning,
Corin.
London. Absolutely.
Oh yeah, Corin's a regular over here. Bill
Bill,
says,
yeah.
"What
Go
brand of
ahead.
eyepiece do you recommend?" Oh man, that's a rabbit hole right there.
Yeah, it is. We always talk about these religious battles, and astronomy and eyepieces are certainly delve into that category. But look, there are certain brands where it's hard to go wrong, right? And you and I and the three of us have spent many nights at Texas Star Party and other places like that, really looking at two comparable eyepieces from different manufacturers and saying, man, this is really nice, but this other one is right there too, right? And so for me, it's a matter of value, right? You can get a really nice eyepiece from a company like Teleview, and it's going to perform beautifully. And then you can get other eyepieces from companies like Explore Scientific that are a little less expensive. In some people's opinions, better than what you get from Teleview. Other people will say, yeah, it's not quite. You get maybe a little more, fuzziness, coma, things like that out on the edges. But there are certain brands you can't go wrong with, and I love the Teleview line. I love the Explore Scientific line. There's several of them that are just the Pentax line is really nice. Yeah.
Pentax, yeah. I can echo all. I think what Explore Scientific makes is a fantastic product, but
Yeah.
in my humble opinion, it is not as good as Teleview, and the price difference reflects that. So,
Right.
there's no smoke and mirrors there. But if you're a beginner, serious visual astronomer, Explore Scientific is a great way to go because their eyepieces are all over the place. They're out there, and there's one there. Which one is that, Joe? Is that the 30?
This is the 30, 82 degree argon purged waterproof. There you go. On the backside, I don't know if you can see that.
It's literally a grenade.
It is a grenade. I mean, in my hand, it's, both of these eyepieces are just wonderful eyepieces. A couple of years ago, Will, I don't know if you remember, there's something called the Holy Hand Grenade, the 31 millimeter Teleview Nagler, which many people regard as the finest eyepiece you can buy. Some people will, there you go, right there. And at Bram, I think
stock. There we go.
I happen to have one on my person, right?
Mine's bigger. Look,
but
mine's bigger.
So the 31 Nagler and this 30 Explore Scientific are comparable in many ways. I mean, we put these two eyepieces in the same telescope back and forth, and there were probably 5 or 6 of us looking at it and then saying, hey, which one do you think is better, right? It's almost like going to the optometrist and say, option A, option B. And it was pretty evenly split in terms of what people thought was better. I think, in this particular case, what we were judging, I think slightly more people said the Teleview was nicer. But then again, this Explore Scientific was roughly half the price or something like that. So, again, it's a matter of, for me at least, of value. Do you want kind of top tier and say, hey, this is what I want, or do you want something that's almost as good? And in some people's opinions, as good or better. for a little less price, right? Whereas you can get 2 eyepieces for the cost of that teleview. So,
and don't buy before Bram says what he's about to say, because I know where he's going with this. Don't buy eyepiece cases with all the different. Don't buy those accessory kits like that.
Yeah.
Don't do that.
Yeah.
So
Save
I
your
was going to show that actually because I have one here.
Yeah, save your money and spend it on these Teleview like these gentlemen have here. Like one of those, I do not recommend at all.
So you often get a case like this when you buy, say an 8-inch, Schmidt from Celestron or Mead or something else like that. And look, if you're just getting into it, they do give you the option of having a few different eyepieces. Some of these kits come with, 6 different eyepieces. You get these filters, color filters, neutral density filters, and things like that. It's not a bad way to go when you're getting started if it comes with the kit, right? If it comes with the telescope that you're buying. But like Will said, I wouldn't spend the money on it, right? I would immediately take, if you're looking to buy a telescope, add about 30% to your budget and go buy 2 good eyepieces with that 30%. So you usually get, this is a 25 mil eyepiece, 25 millimeter Plossl, very common design for, the type of telescopes that you get these things with. And look, they're fine. I mean, they do an okay job. But when you're really looking at a 21 mil ethos, and again, this is a really nice eyepiece compared to what you see through this 25 Plossl, it's night and day. It really is just a huge difference in the quality of what it is that you're observing. You've got a much wider field of view. You've got much crisper images all the way to the edge. It's just, you really can't compare the two.
Yeah.
Eye relief, things like that. Yeah.
I only have 3 eyepieces.
Yeah.
And my PowerMate. And honestly, sometimes I wish I didn't even have the PowerMate. I would rather have a third Delos and forgo the PowerMate.
There you go.
It would have been a little bit more money, but it's so rare that I put the shorter eyepiece on that PowerMate.
So here's a Delos. Bram mentioned the Delos. It's another Teleview eyepiece, right? You can see the Teleview logo there. 10 millimeter Delos. It is kind of the line that is just below the Ethos line from a Teleview perspective. Some people say the eye relief is better with Delos, and you get better views out of the Delos than you do the Ethos. I've heard that from a lot of people, and it's a much lower price point. So trying to find the eyepieces that are best out there. You're going to get a lot of people saying the most expensive ones are the best, but you can find a lot of really good stuff out there that's not quite as expensive.
Yeah.
I did run into one guy who had, I think, a 10 millimeter Delos, and he hated it. He said, I just can't get a good view through that thing. And I was like, that doesn't make any sense at all. The guy had like a 25-inch Dob. He's one of the regular guys out at Columbus. And I was like, let me have a look, right? The problem was he didn't know that you can unlock this and slide this up, right? This feature is made so that if you wear glasses, you need that extra clearance for your glasses. So this is how it comes out of the box, but you can unlock it and then slide it up. So if you're not using glasses, this is where you want to be. Now you have the right eye relief, and it really helps you get the right position. And on that particular focal length, it made all the difference in the world. He wanted to get rid of the thing, and then I unlocked it for him, showed him this. He's like, oh wow, that's so awesome.
It was like a hidden feature.
Yeah.
An Easter egg.
Yeah.
I just took the rubber cup, and this is another one that I absolutely love. This is the Teleview 13 millimeter Ethos.
Oh
right
yeah,
there.
that's a magic number right there.
Yeah, you can see down below it's a little different. Whereas the 21 Ethos is a true 2-inch eyepiece, the 13 is both a 2-inch and an 1.25 inch. So you can use it through either of those two types of what's the word I'm looking for?
Have you used that
eyepiece holders?
Yeah.
Yeah.
Have you used that in an 1.25 focuser? I guess
I have actually. Yeah.
Yeah.
It's awkward.
It's nice and stable. It's awkward. It looks like the nose is
a little
too
awkward.
Short.
Yeah, it's a little awkward in an 1.25 inch. Depending on what your 2-inch adapter looks like, sometimes you can actually bottom out if you're using a diagonal mirror or something like that. So you have to be careful with that as well.
Yeah. Definitely.
Hey,
So,
I need to give a shout out to somebody here.
yeah, this one right here. There you
Yeah,
go.
there he is. Emilio, how you doing, buddy? Emilio here is a really cool guy I met, gosh, I don't know, maybe like 6 years ago. He came to Houston, and he's from Nicaragua. And he's one of the head honchos at this organization down there in Nicaragua called ASAFIL. I hope I'm saying it right. Let me share a screen here and show you some of what's going on down there. Let's see.
And I see the other questions, Marcia.
This one.
We will get to your question. Don't worry.
So here's his Facebook page, or his club's Facebook page, ASAFIL, Asociación de Astronomers Aficionados de León. And I think that might be Emilio right there. These guys are doing so much outreach down there. It is awesome. I mean, I haven't seen, well, here, this is November. So
wow.
yeah, they're back at it.
Look at those lines. Amazing.
Yeah, yeah,
Wow.
it's just super what they do down there. And it's not just public outreach like this either. There's Emilio for sure. That's him right there.
Nice.
They got a lot of nice I guess they do some live streaming and whatnot, have different guest speakers. It's just terrific stuff.
Yeah, nice.
Amelia, are you still there? Are you still in the chat? Let's see.
We might hear
We'll
from.
see if he comes back on there. Yeah.
Thank you, Shawnee.
Mahalo to you too.
While we're doing that, Bram, did you get? I mean, because we got a couple of questions, but before we get to that, did you get anything new for the holidays?
Yeah, we haven't seen what you got, Bram.
I guess I'll have to show you this little gizmo. I'm actually using it right now. This is a little mixer that has USB, bidirectional USB input and output. So this allows me to connect it to the laptop, and so I'm basically talking on this microphone through that mixer. Yeah, Emilio's here.
There he
Super.
is. We can hear Bram in actually some decent quality because of this tool.
Yeah, there you go.
It's really nice. And this is going to be my carpool karaoke centerpiece too. Finally, a solution for the car. I love to sing, and now I can be on the mic and piping it through the speakers in the car. Maybe I'll
Just
even be
mounts
able
the
to
speakers on the top of the car. There you go.
Yeah, and yell at the people next over. Hey,
Share your
brake
gift with
lights
the rest
are
of the
out,
world.
you clown.
Use your blinker. That's awesome, man. Yeah, and I mentioned that at the top of the show that you actually have a microphone now, which is impressive. You're moving on up in the world, Bram.
Yeah,
So
I've actually had this microphone for a while. It's been with my regular karaoke stuff. I do take song requests. So if you have any, just send me a message, and then meet me over at Wildcatter Saloon next Thursday and buy me a beer, and I'll sing you a song. How about that?
there you go.
Wildcatter Saloon in Katy, Texas, right?
Oh yeah. That's
Will you sing? Can I give you a beer to not sing a song?
One.
Only one. That's awesome. Well, good. Glad we got Emilio in here doing some good work down there. Keep it up, buddy. The world needs outreach, like Bram said.
Absolutely.
We need that now more than ever. So it looks like it looks like the demand is pretty high down there, and it was mostly kids. So that could be the next generation of Nicaraguan amateur astronomers.
Yes.
Indeed, more than likely, that's exactly what it's going to be. So,
Emilio, when are you coming back to Houston?
it'll be a minute before he hears that.
Yeah.
Yeah.
But we'll pose that question for him. So
yeah. In the meanwhile, we did get Marcia asked us a question. What's a good telescope for personal use? Man,
so
we're
many
the tough ones today, right?
Yeah. There's a lot of factors there.
There are, right? A lot of people, it depends on what personal use means to you. I know for some people, look, I have a 25-inch telescope that I bought from a guy who said, you know what, I'm older in age and I just can't use it anymore, right? And so, whereas he was able to use it earlier in life, he just can't use it now. So for him, personal use was a 15-inch telescope, which is still a nice big telescope. Other people want something they can just grab and go, throw it in the back of the car, put it in a small case, like maybe a nice refractor. a 6-inch, Dobsonian or an 8-inch Dobsonian, something like that.
20-inch
But
Stargate.
I guess, when people ask me, yeah, there you go. Marsha, when people ask me, and Bram and Will chime in on this, what's a good telescope for personal use? My first question back is, well, what do you want to get out of it, right? Do you want to do astrophotography? Do you want to do visual observing? What kind of things do you want to observe, right? Because look, we can point at two different objects in the night sky, and one telescope will see that planet better than the other one will, but that other telescope will see the galaxy in better detail, right? Or at least give us better images and things like that. So it really depends on what you want to do with it.
Absolutely. Yeah, and I would say, where is your budget limitations at? Because like Joe said, if you have unlimited budget, 25-inch Dobsonian is the ultimate way to go. That's just because, like Bram said earlier, aperture is everything.
Yeah.
If you buy a 6-inch telescope and expect to see, Hubble images. I mean, you can buy a 25-inch telescope and expect to see Hubble images. You're going to be disappointed because, like we said earlier, those cameras are open for hours collecting all that faint light. That 1 photon a minute that's coming in from that nebula. Well, if you leave your camera open for 60 minutes, you have a ton of photons there, whereas your eye, it's not that good at doing that. So like Joe said, it depends on what you want to do with it. There's a lot of factors involved. And it depends on your price range. I am of the opinion that, and people don't want to hear my recommendations half the time because I'm like, well, do you know your constellations? And they'll immediately say, no. And
What's
I'm
a
like,
constellation?
well, it's a,
My doctor told me to eat more fiber.
that will help. You have a high fiber intake. You can see Hubble images, but no.
That helps with constellation. Big time.
Yeah, it helps a lot with constellation. Gets rid of it altogether. If when people ask me this, I immediately say, "Do you know your constellations?" And typically the answer is no. And my response is, "Don't buy a telescope until you know your constellations."
Yeah.
Because that's what I did. And I have had nothing but success with telescopes. Okay.
Yeah.
Because you might be like, well, why? What does constellations have to do? Well, if you know the roadmap, then you know where all the towns are in the place, right? So when I look up at the sky, I don't even really see Orion and Leo and all these other constellations. I see a roadmap. And I'm like, and you tell me, oh, that's in Orion next to Mintaka. And I'm like, oh, well, I know exactly where that is because as a kid, I was obsessed and learned all that. And luckily, I've been able to retain it. So I can just point my telescope over there. If you don't have that knowledge, there are telescopes that contain that knowledge inside of them. But now you're talking into the $1,000, $2,000, and $3,000 range.
Yeah.
Whereas I can find you something manually in a telescope that's $200 or $300, and we'll see it. And you'll see it in that other scope that's $3,000. We'll probably see it pretty similarly, right?
Yeah.
So there's just a lot of that kind of stuff. Under 1,000, yeah. So, man, I'm reluctant to even recommend binoculars, but for $100 or so, you can go out and get a taste of what telescopes can do. The only thing binoculars lack is stability because you're doing this,
Unless they're image stabilized.
Which
That's
now
true.
you're talking about $1,000, but yes,
Right.
Totally worth it.
No, you're not lying. No, those image stabilized binoculars are the bee's knees, man. Good stuff.
Well, and then the other thing I would say is, look, there are the two things actually. One, there are certain things that you are going to observe through binoculars that look a heck of a lot better through those things than they do in any telescope. Period.
Mm-hmm.
There are a handful of things where, it looks better in binoculars, right? The other thing is, as we talked about, you need to budget. So if you've got $1,000, you still have to budget. You're not going to buy the Delos or anything else like that. But I would set aside probably $300 and buy two really decent eyepieces as part of that $1,000 budget. So then that gives you $700, minus taxes and things like that, to play with when it comes to buying that new telescope. So, and quite frankly, I think 30% is probably not high enough, right? Because you still have to get, the Telrad and some of these other things that go along with it.
So start collecting now. Yeah. And start small. That's my advice. You know,
Yeah.
you don't have to go out and buy this thing, because what happens to a lot of people, and I see it so often, is they go out and they spend $2,000 on a
Yep.
computerized telescope that tracks and does all this stuff. They put it outside and they have absolutely no idea what they're doing. Okay. But you
Yeah.
can go on YouTube and watch some videos, and now you have like an idea of what you're doing, but no practical application of that knowledge.
Yeah.
And that's a really it's a bad recipe for disaster, because what happens is a lot of people get these things, they can't find nothing, and they put the
Mhm.
scope in a closet, and there it rots forever.
Yeah,
So,
I've said this before. You know, I think nothing has killed the aspirations of people when it comes to learning about astronomy more than the marketing departments of telescope manufacturers, right? When they start advertising 700x power, 800x power, things like that, with these, telescopes that you spend $150 on, people
mhm.
have expectations that it's going to work a certain way, or, like Will said, there's a lot of complication in trying to get a computerized telescope to work, and people just quit out of frustration, right? And it's a shame, because they went into this with, great intentions of wanting to learn about astronomy and things like that. But then the equipment creates enough frustration that they just say, you know what, I don't want to deal with this anymore. So, at the Houston Astronomical Society, we get a lot of donations from people who said, you know what, I didn't learn how to use this telescope, and we were frustrated, and we just want to donate it, right? That kind of thing. I remember somebody donated a Zoomel Z8 Dobsonian telescope, 8-inch Dobsonian, nice telescope,
Yeah.
to us several months ago. And I went to go meet this person to pick up the telescope, and I looked at it and said, I don't want it. And she looked at me, I said, I want you to learn how to use this. And, she gave
Beautiful.
me a couple of other excuses as to why she couldn't, they were moving and they just didn't have the space for it and things like that. But, for me, I wanted to, make sure that the reason she was giving up that telescope went beyond just, hey, I was frustrated with it. And, the funny thing was, she was complaining about how big and bulky it was. And when I couldn't talk her out of it, I said, okay, well, appreciate the donation and everything else like that. I unscrewed one of the what do they call it? Not an adapter. They're on the rocker box, the tensioner screw
Oh,
or whatever
like
it
the
is,
chuck
the
for
chuck or whatever it is, to
the
take it
atmosphere.
off the rocker box.
Okay,
And
yeah.
so I unscrewed that so I could lift the telescope out and put it in separate from the rocker box. And she looked at her husband and just kind of, they gave each other that look like, huh, we didn't know we could do that. It would have been so much easier to transport this thing. And I gave him another chance. I said, look, now that you know this is how you do it, you sure you still don't want it? And they said, no, we appreciate it, but some point in the future, we'll probably get back into it. But again, that goes back to your point, Will. Learn how to use whatever equipment that you have, learn to navigate the night sky beforehand, and that makes the experience so much better.
Yeah, and there's small little getches that will get you along the way. Let's say you just got this new scope and you finally run across a warm, beautiful night where it's absolutely clear, and you're like, yeah, let's get that thing out. And you're in your nice air conditioned house, and you grab all your cool gear and you put it out in
Yep.
the backyard, and it's a nice warm night, and you got it all out there, and then you go to look through it, and all you see is fuzziness. Even on the moon is fuzzy and
Yeah.
distorted. Well, you need like an hour or more to
Yeah.
acclimate that temperature on that glass. I mean, I don't have any glasses that are condensing here, but if you have a glass full of ice water, what happens on the outside? It gets dewy and messy. It condensates, right? And that's what's going to happen to your optics when you take it from the cold, air-conditioned house and put it out in the muggy backyard.
Yeah.
So there are little bitty catches like that. That you may be doing everything perfectly. You may have even taken my advice and learned the constellations, and like that right there, the Orion Nebula, we're going to hit it. And then you got everything out, and that was one thing and then you may be getting bitten by mosquitoes or, whatever. A friend yells at you to come check this out, and you get distracted, and then you never really connect with the hobby that way. So just remember that there are some little caveats there. The best advice I can give, and I bet you Joe and Bram will echo this, is join a local astronomy club before you
Boom.
buy anything.
Yeah.
Because if you do that, especially like the Houston Astronomical Society, these guys have these scopes that people just wanted to throw out because they couldn't figure out how to use them. Well, guess what? Now that scope that was going to end up in the garbage is something that if you join their club and they know who you are and you've got a friendly rapport and everything's good, you might even be able to take that scope home and loan it out. And not only that, but it comes with like an expert who, before you take it home, they'll be like, well, do you have any questions? And you, well, yeah, actually, what happens if I do this? Then they'll explain that to you.
Right.
It's the most powerful thing. It's like, you could sit there on Google for 10 hours, and I guarantee you that 1 hour you spent with experts like Joe and Bram at the Houston Astronomical Society, you're gonna usurp all that 10 hours of searching you did, and that 1 hour is going to be more powerful for you than anything you could have seen on YouTube or anything like that. So,
yeah, no, that's a great point, Will. I would say, sorry to interrupt you, Bram, but to echo your point, if I were getting into this, and you have $1,000 budget, I would spend the, $30, $40, whatever it is, to join a local astronomy club and figure out what I want to borrow from there. So, we're all members of the Houston Astronomical Society and of the Astronomical Society of Southeast Texas. And, we've got a wonderful telescope loaner program, right? So when you join,
I posted the link.
Oh, did you? Okay, perfect.
yeah,
Bram, I think the last count we had 44, 48 telescopes in our loaner program.
Wow.
Which is quite significant, right? And so, the deal is, if you're a member, you can borrow a telescope for up to 2 months and, test it out and say, hey, do I like it? You'll be amazed how many people say, I want to buy a certain telescope. Before they go out and buy it, they borrow one from us, and then they realize, hey, this thing doesn't fit my car. So, can't buy this telescope, or I've got to buy a new car. Now, all of a sudden, that $1,000 telescope becomes a, $35,000, $40,000 car that goes along with it too, to haul it around. So that is, one of the benefits of joining a local astronomy club is many of them have loaner programs where you could just borrow a telescope for a while, figure out what you like, what you don't like, learn the night sky with it. And as Will said, learn from others in the club, learn how to use it, as opposed to having to Google things and watch YouTube videos that may or may not be right. And really get the most use out of it. So
I'd like to say a few things about GoTo. So there's lots of seasoned astronomers that will steer you away from GoTo because it's a crutch and you're not going to learn the sky. That's valid. I've also run into people that buy a GoTo telescope and can't figure out how to do the alignment to get the GoTo to work. Okay, it's not always easy. The other issue I've seen is that these most of the GoTo systems, they don't take into consideration the size of the aperture of the instrument or the fact that you're in a light polluted sky. So I went through these pains. My first telescope was a Meade Nexstar. No, not Nexstar. That's a Celestron. It was a Meade 5-inch. I can't think of what it's called anymore. But anyway, it was a Meade 5-inch GoTo scope. The views were awesome. It was a Mac. It was a cast.
ETX.
It was a Mac cast. ETX.
Yeah.
ETX
The ETX. Yeah.
Yep.
Great optics. Horrible. Yeah. Horrible.
The views
drive.
of Saturn.
Yes.
I've never had views of Saturn like that since. I swear.
Yeah.
F15. But, I'd do the alignment, and then it slew to an object. I'm like, okay, that's cool. And I'm doing the tour, right? It's got this nightly tour thing, which sounds awesome. And then I'd slew to another object, and I don't see anything, and I don't know why. Is the GoTo bad? Did I kick a leg? I don't know what's happening, right? And probably looking back on it, it was probably just something that was too dim for that aperture and the sky that I was working with, right? So that's really frustrating. Now there is a new product on the market, and I think you have some experience with this one, right?
Mm-hmm.
Celestron's got this new thing, StarSense, right? There's got a couple of versions of it. There's one that works with your phone that mounts on a relatively inexpensive scope, right? And that does take into consideration the fact that you might be in an urban environment, and then it'll limit the selection of objects. But still, you're talking about small aperture. You got any other comments about that device, Will?
I wanted to kind of talk about that one so Celestron has a couple of different things that are that are really useful for that. But the StarSense Explorer, and I guess let me just share my screen. How about that? Since we're on the subject here, because it's a great thing. I endorse it 100%. And I'm not being paid to say that. And that, I think, is the window. There we go. So let's click on, don't get this one. Don't get the 130. That's just my opinion.
Is that one of those janky ones with a Barlow in the focuser?
It's a Bird Jones Newtonian reflector.
Stay away
Bird
from
Jones are absolute garbage.
Bird Jones doesn't fly.
Yeah, it's definitely not. I'm sad that people still make a Bird Jones, to be honest with you. They're utter nonsense because they can never get that little Barlow correct. They just can't.
And you can't collimate through the darn thing.
No.
Exactly. Yeah, it's basically useless if it gets knocked out of alignment. Whereas a refractor, even though this is a cheaper refractor, doesn't need collimation or aligning every time. So long story short, if y'all can see this, maybe if I zoom in, does that help a little bit?
Yeah.
Okay.
Looks good.
So what you have is the telescope here is on this side. Okay. And this is where your eye is going to go. This little guy is useful, but pretty much not even really needed. This is how you're going to focus the telescope right here. And it's got these slow motion controls that you can put your hands on and kind of turn, and that will slowly move the scope. Now,
up, down, and left, right. Yep.
Yeah, just like an altitude azimuth mount, as we call it, up, down, left, right. Now, this is the piece right here. So you can see there's a smartphone here, and I believe it'll work with Android and iPhone. Yeah. Although I'm gonna definitely say it absolutely works with iPhone.
BlackBerry.
Not anymore, Dick.
Yeah, it's the last day, actually. Yeah. Not anymore, but no,
not anymore.
This system is super genius, man. And whoever came up with this at Celestron deserves a Nobel Peace Prize or something. I don't know. What it is under this area right here that you can't really see is a mirror. Okay. The light, I know it shows it backwards, but let's say the light from Saturn and the stars that are in the sky comes down this way and it hits this mirror and it bounces up into your cell phone. When you buy this StarSense DX Explorer telescope, it comes with a QR code for a download to the software that you need to run that on your cell phone. And once you have all that done, and it's not hard, it takes about 5 minutes to get that installed. You do a simple alignment procedure with the telescope. You point it like a street light, and you get the telescope pointed at the street light, and then you get your phone. There's a little alignment procedure. You get everything on there pointed directly at the street light. This telescope now knows where it is in the night sky because of something that we in the astrophotography world use called plate solving. And long story short, that's a picture of the sky where a computer goes, you're in Orion. Because this is nowhere else. These stars that I'm seeing are nowhere else but in Orion. Okay.
Pattern recognition.
Yeah. So it's pattern recognition. And then it's amazing, y'all, because these arrows that they show here on this little thing will actually tell you which direction to move the scope. Let's say like I want to look at Saturn, but I'm not sure which one of those stars up there is Saturn. So I tell the software everything's aligned. I say Saturn, and it'll put these arrows up. And so I just take the scope manually and push it to that area. And Saturn is in the eyepiece. And I'm not like that's exactly how it happens. It's extremely accurate. It's so accurate you can bump the scope, just like bump it, and you'll see that represented on the phone. You'll see the phone kind of do like that because it feels all that with the accelerometers in the phone and everything. The problem is you do have to have a smartphone, and for some people I know they might not have those, but for those of us that do, and you want to spend around $500, this is a great way to get really get that bug that we were talking about earlier, because a couple times using this thing and you're going to be finding everything you want to see. It does know that you're in like a city. You'll tell it kind of like where you are and stuff like that. So it knows that you may be in a light polluted area, and it'll tell you this object may not show up very well, or this object is actually really decent. So the best thing you can do for this little telescope is take it out to the countryside with your family. Go out to your favorite ranch or your favorite wherever out in the middle of nowhere, and you will see those things, no problem, because it's like a 4-inch refractor. I think it's 4-inch, right? 102. Yeah, it's 4 inches.
Yeah.
So you can see a whole lot of stuff with this in that size range. You're not going to see the amazing detail we will in our half-meter scopes, but you'll see the objects with this scope. And then I can click on this, and it actually shows that mirror in there really well and how that system sort of works. It's using Sky Safari, like a weird version of it, but it is Sky Safari, made by Simulation Curriculum, as far as I know. Yeah, if you don't know the constellations and you can't find stuff in the sky, this is a great scope for you. It won't break the bank. It's easy to set up. It's light. It's portable. I have one of these, and
Can I have it?
for a day. But no, I wouldn't even get rid of this thing. I love it.
I would love to have that for urban use, because nowadays you can't even hardly find enough stars to do an alignment on, or to star hop for sure. So getting back to GoTo, one of the things I like about GoTo is it can really save your butt if you're in the city. You can't see enough to star hop to, but you can probably get enough stars to do the alignment, and then let the GoTo take you where you need to be. And I've certainly had GoTo save the day at many of a partially cloudy night trying to do outreach.
Yeah, absolutely. GoTo, once you have everything aligned. Yeah. And like Bram said, that can sometimes be the kicker. You need to know where Algol is, or Zubanel Shamali, or Mintaka, or Algorab. I mean, Aldebaran. There's thousands of these star names.
Hakuna Matata.
Hakuna Matata. If you don't know which one those stars are, you might as well. I mean, it might as well be any of them, right? Yeah. So knowing your star names is like, I tell people to learn their constellations. Learn a star name or two in there as well, and it will. I promise you, it will come in handy.
It comes in handy.
Yeah, for exactly what Bram said. If you don't know those stars, you can't really align your GoTo. Anybody can get like latitude, longitude, all that's on your phone these days. That's easy. You can figure out what time zone you're in and program all that into the telescope. And then it was like, you ready to align? You're like, yeah, I'm ready to align. And then it's like, put it on Zubanel Shamali. And you're like, okay, I can't even read that word. Okay, which one is that? And that Zubanel
What'd you call my mama?
It's a bad star because it's in Libra, and Libra's barely visible.
You can, barely see it. Exactly.
Yeah, even at a dark sky site, you're like, is that Libra? No, that's part of Scorpio.
Yeah.
No, that's Libra, right? Yeah, it's okay. Anyway, but yeah, and so like what Bram said is 100% true. Something like this can show you more in a few hours outside, than spending all night on a $3,000 telescope trying to get the thing aligned and calibrated.
Yeah.
So.
And I've told people this too, right? And it's not just telescopes, but the best telescope out there is the one that you're going to use the most, that you're going to learn from the most. And I know people who have used, I guess we've gotten to a certain point now where we have pretty nice equipment, but I know people have learned a lot and done a lot of observing with, fairly modest telescopes. So
sure,
you don't need the $20,000 telescope or anything else like that to get good use out of it and to really grow as an amateur astronomer. So
yeah,
something like what you just pointed out, Will, that telescope is great to get people introduced. It kind of reduces those technical barriers that a lot of people have. Look, I started off with GoTos, and the use of GoTos so I've had, Celestron GoTos, I've had Meade GoTos. The process of setting them up is completely different between the two companies, even across, the lines. Some of them will say you've got to have it pointed north and level before you even start. And when you do that, you have to put in the date, time, location, the GPS coordinates. If you're off by a minute or two, then it's going to throw the GoTos off and things like that. It's just a lot of frustration that, you just don't want to deal with when you're getting started with it. So, a telescope like the one you pointed out is really good at getting people the opportunity to really start observing with the aid of computerized device and helping them locate, certain things, but without all of the technical challenges and hurdles that a lot of people had to overcome with some of these go-to devices. And quite frankly, there are nights where the go-to it's finicky. You would think, hey, this is software and hardware, it should work the same time every time out.
Mhm.
There are times when it just doesn't want to go. And again, you'll find that like with my Meade LX200, if you don't train and calibrate the drives and do things like, just all these things that you have to do in order for it to compensate for the slop in the gears and things like that, then the go-tos aren't going to be worth a damn, right? Or they'll be okay for the first 20-30 minutes, and then they progressively get worse as the night goes on. So that's why, like you said, that device that that engineer at Celestron created is pretty ingenious.
Yeah, I've seen people buying that whole setup, taking that piece off of that scope and putting it on their 20-inch Daub.
I've been tempted.
Yeah, and apparently that's kind of a thing. Like, here, kid, here's a free telescope because I got what I needed, and then it's literally clamp it to the telescope, and once you get the telescope and that plate solver aligned, you're done. It's over.
So here's a funny story about Celestron go-tos. I have a Nexstar 6 SE, and I think all the Celestron systems are pretty similar. One year I got out to Texas Star Party, and there was several people on the field that had 6-8-inch Celestron Nexstars, and they couldn't get the go-tos working right. And they were using this feature that ordinarily I love. It's called Skyline. The cool thing about Skyline is you don't have to point at named stars. You just have to put it on 3 different bright stars, center it on each one, hit a line, go to the next one, a line. You do 3 of them, and it does a plate solve, right? And these guys had done it successfully in the Houston area or wherever they came from, and then they got out there to TSP, and they couldn't get it, and hours of frustration. They even asked the Celestron rep who was out there. They didn't have a clue. And I figured it out. I mean, the problem is you get out to a really dark site.
Yeah.
It's hard to identify the 80 programmed alignment stars that computer's looking for. So you really, at that point, need to do an alignment on named stars that you can, identify. There's a Zubanoobadoobie.
Yeah.
I've had that issue with the StarSense accessory. I think that's what it's called. The StarSense accessory.
The camera, right?
The camera that mounts on the scope.
Yeah. It's just one of these things where if there are too many stars in the night sky, it gets confused. It's
just like us. Yeah. I remember when I was a kid and I knew my constellations, man. I knew where Orion was. I knew where Virgo was. I remember my first time going out to a truly dark area in Arizona, and I got out there and I'm like, wait, what? Where's everything? I mean, because it blends in because you're starting to see down into the magnitude 7 range, and good luck finding some of those constellations. So yeah, like Bram said, sometimes you get to an area where there's too many stars. And so, but yeah, you definitely want to make sure you're doing that. But Marcia had a question. There's a group in Beaumont, Port Arthur. There is. Yeah. We're called the Astronomical Society of Southeast Texas. And we meet on the second Friday of every month. In fact, we have a meeting coming up, not this Friday, but next Friday, which is the 14th or something. I'm not exactly sure. So Marcia, Google Southeast Texas astronomy or something like that, and you'll find us. You'll find our Facebook, our Twitter, the website we're working on. We need to update it, but all that information is correct except for the October meeting info. But we do meet at the Murray J. Frank Planetarium, which I saw was part of your question there. Is a planetarium the best place to go? No, the planetarium is kind of like one of those places you go to get inspired to go observe. To do the best astronomy, you want to go out to the middle of nowhere. And so we do have that. We have a Facebook where we post like most of our happenings, where we'll be. We did have a star party scheduled for this Saturday, but we had to cancel it due to weather because we're Nostradamus and we know what the weather is going to be like coming up. And so instead of deploying our astronomers out to, we just called it. But that will be, we rescheduled it for February 5th at Sea Rim State Park. And if you're from the Southeast Texas area, I guarantee you know where Sea Rim State Park is.
Yeah.
So please come out and join us on February 5th. Those events and stuff like that can always be found on our Facebook page, which is Astro SETX, I think. So if you go to Facebook and you type in Astro SETX, you will find us. So, and they say yes. So yeah, I saw this question pop through. 130 EQ is good for astrophotography. No, unfortunately, no, especially without a tracking mount, because Vishal, you'll need to be able to follow the sky as it turns. So Earth is turning at 1,000 miles an hour, right? That's how fast we're spinning. To counteract that, you need a computerized mount like we've been discussing to keep that one star in, you know what I mean? It's got to follow. And that's the golden ticket for astrophotography. Now, like what Joe said earlier, you can get an untracked telescope pointed at the moon with your smartphone or some kind of little camera and take pictures like that. But if you're talking about astrophotography for like nebulas and star clusters, galaxies, that sort of thing, you're going to need a way more professional setup than those little 130 EQs. As a $300 telescope, so it just doesn't really cut the mustard, is a saying I've heard and that I hate, and I can't believe I used it. So there you go. Unfortunately, not with that mount. Cool. Thank you, Marcia. Thank you for joining us. We appreciate you. What we got here? Suburban Astronomer. I use my phone and a planetary app to locate named stars when I can't find any I recognize. So there you go. And Joe's got it brought up there. And Joe's just got like an iPhone. And you can see all the named stars and everything right there is all labeled for. That's Sky Safari, correct? Yeah.
That's Sky Safari. And you can
And there it
see
goes.
now it just, switches over to use the compass, the accelerometers, and everything else in there. So you can actually point this at certain parts of the sky and get a good general understanding of what it is that you're looking at. It showed it earlier. Let's see if I can get it to lock up there and get a focus, but you can see that ring. Yeah, I'm not getting focus. Hold on 1 second.
Twist.
You see JWST.
There you go.
James Webb Space Telescope. So in addition to stars and other things like that, you can actually use these planetarium applications to track satellites as well, which is pretty cool.
Yeah, absolutely. And those apps are invaluable when it comes to learning the sky. There's free ones too. You don't have to pay for some of these apps. Stellarium is a great one that's free. It does everything Sky Safari Pro and all those other Star Walk or any of those other apps. I only recommend a few.
Right.
I won't recommend Star Walk or any of those other cheaper ones. I just don't recommend them.
Right.
I'm sure people use them with great success. I don't recommend them. I say Sky Safari, Stellarium. If you want to spend some money, there's the Sky X, but that's definitely not. I'm gonna get Bram a high five slowly. But there's a bunch of them out there.
I'd like to talk about Sky Tools.
Oh yeah, that's another great one.
So Sky Tools, I have to give credit to Sky Tools for really opening up my enjoyment of this hobby. I'm a visual observer, and as I mentioned before, I was frustrated by, what can I see in these conditions with this telescope? And I'm going to show you Sky Tools here. Let me do a little screen share.
While you're bringing that up, Bram, I just wanted to mention one thing. So I usually categorize astronomy programs in two different categories. Some people will say three, but you have the planetarium software, which is kind of similar to what I was showing earlier. And then you have the planning software, which is, I put Sky Safari in that planning software category, but it does do, some of the planetarium functions as well. So go ahead, Bram.
Yeah, I guess with that, I would have to call Sky Tools Planningtarium. It's really powerful. Okay, so you start out by setting up the site that you're observing from. So I'm going to put it on Katy here, which is where I live, and you can describe all your equipment. I've got my big Zoom L binoculars here. I got my 20-inch Stargate. I got my, let's see, my Orion XX12G. It's my grab and go. So it knows all the characteristics of these things. You can even describe yourself. It'll have your age, and it'll estimate your pupil diameter based on your age. If you know your pupil diameter, you can override that. We're getting down into the weeds here, but the 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 nuts and bolts of it is then you can have a list of objects, and it comes with some default lists like the Messier objects here. So I'm on the real-time observing tab, so it knows where I am, knows what equipment I'm using. So it already knows what the sky brightness is, and so here's a list of, let me reset my filters because it's reset the filters and refresh the list. This is curious. It's saying 111 of 111 objects meet the criteria. Something seems a bit amiss because they're not all up right now. I'm not going to fret over that right now, but it is showing like these columns here, begin, best, and end. These are times when you can start to observe the object, what time it's going to be highest overhead, that's when you'll have your best views, and what time it's going to end, and the difficulty. So for the Orion Nebula, it's going to be apparent, right? And it'll make a guess at my ideal eyepiece. And then if you want to view it, you can hit the T for the telescope view, and by default you're going to get, let's see, it's not showing my finder view. That's odd. There's something wrong with this XX12G. I'll switch to the Stargate. All right, so now we can get 3 different views here. So this is going to help me to star hop. Joe showed you his
So
Telrad
Bram, we're
earlier.
not, sorry to interrupt you. We're not seeing that other screen this one.
Oh, okay. Thank you for telling me that. Yeah, it opened up a window, so I gotta come back here and share again.
To be honest, this is one of my gripes with Sky Tools. I tried using it like 3 times, and I'm like, no.
I love Sky Tools. My biggest gripe with it is that they don't have a Mac version.
Okay, can you see it now?
Yeah,
we
got
can.
it.
Yeah, there you go.
Okay, so here's the 3 different views. In the upper left, we have the naked eye view, and it's got the Telrad rings projected on the sky. So it's showing the Orion constellation and how you would align your Telrad to be over the Orion Nebula. And then below that, we have the view through my Stellar View 80 finder scope. And so I'm going to just zoom out a little bit so you can see the whole field of view. So this circle is the field of view through that Stellar View 80, and it's simulating with pretty good accuracy the stars that I would see in each of these views. Because I'm in Katy, I'm not going to see a lot of stars naked eye, so there's only a few bright stars shown here in the naked eye view. We see more stars in the stellar view, right? And then over on the right, we have the eyepiece view. And you can change the eyepiece. It's showing the 12 millimeter right now. I'm going to go to the 31 millimeter Negler, and you see everything rescale, right? So if you want to star hop, this is a very easy and accurate way to do it. And you can print these charts out if you want to take paper into the field, or if you feel comfortable bringing your laptop into the field, you can do that. The nice thing about bringing your laptop is you can also log your observations. So
yeah,
once I've located it, looked at it, I come back over to this and I right click and create a log entry. And then I can set up some defaults over here. And then that, I don't have to do this for every log entry, but I might want to set my transparency in seeing. And then I create the log entry, and it's, let me say what eyepieces I used, and I don't have to type it out. I can pick them from a list. So I used my 31. I might put another one in there. Okay. And then I zoomed in and I used my 12. Yeah. And it's even calculated the power for each one. It's awesome. You can put whatever notes you want in there. And then when you're going to submit your observations for an Astro League program, you can easily go into the log browsing tool and generate a list and document all of the stuff that you did. So it's really cool. It's not cheap, but things that are worth it seldom are.
Yeah, and this is it's a different style software for a different style observer, because none of us go out and do the same kind of observing. You know, we all have our own little methods and to our madness, right? And this works great for some, like, whereas, you know, for me, I've tried multiple times to get into this software and I just can't. But Bram just tears the sky up with this thing. I think one time at El Dorado, he did 6 awards, you know, just using
6 observing programs.
6
Yeah.
observing programs, which is like 30 objects a piece, just using this style software, right? Because he knew what was up, he knew what he could hit, and he just went down the list and like, oh, that sounds interesting. Let me hit it. And then he hit it and then logged his observation and moved on to the next one.
Yeah, I'm not always happy with the order that it's presented here either. And what I'll tend to do is I'll click the list and I'll highlight an object, and then and what I'm doing is I'm watching these bars up here. So, you know, the darker portion in the center is, you know, when it's nighttime, right? You've got daytime and then twilight, and then you're into darkness, and it shows the moon setting here. It's got an arc for the sun, and then it has an arc for the object that you're looking at, right? So you can see when it's at its peak. This red bar is the current time, and this blue bar is the time where they recommend that you try to see it. And but what I like to do is I'll click on the list and I'll just start tabbing down, and I'll look and I'll watch this. I'm pointing with my finger and you guys can't see my finger. I'll look at this. I'll look at this curve of when it's setting, and I'll try to observe it. I'm not necessarily going to trust the best time that I see on the list there. I'm going to look at that curve and see if things are already starting to set. Like this guy here, I'd rather grab this guy here, M103. I want to grab this before it hits this line. This is the 30-degree line. You want to try to look at things before they get below 30 degrees. So I would go for M103 before I go for Orion, because Orion's going to be high for a while. Yeah. That's one of my strategies.
Yeah. And you need a strategy when you're going out to observe, because otherwise the night can get away from you suspiciously quickly.
It makes all the difference in the world. You know,
Absolutely.
having a plan, and or at least, you know, knowing what you want to see, and you know, working off of a list or something like that. Beats just going out there and hoping to find something through the telescope eyepiece.
Yeah. And I mean, you can do that. I mean, and that's something that, you know, people do.
Yeah.
But yeah, to have a plan is definitely it's gonna help you, you know, regulate your activity out there to where you may only see 1 or 2 objects if you're just hunting around, where you can see 50 or more if you're doing it in this particular style. I'm a little bit different. I use, you know, Sky Safari on my phone, and I just let it highlight objects that I need for whatever list I'm working on. And I just look at it and say, well, that's up, you know, and there it is. And then I just start knocking those objects off on that particular thing. So I'm more of a visual astronomer, whereas Bram is more of a, you know, not an Excel. I mean, that's not an Excel, but it's like a spreadsheet style thing where he can look at it and plan his evening based on, you know, what's going to be up and everything else. It's the same game we're playing. It's just a slightly different method to the madness. So there's tools out there to use for sure.
This thing can even spit lists out for Sky Safari, which is pretty cool.
Very cool.
Another thing it has that I like sometimes is this nightly observing list generator. So let's say I'm just going to go out, you know, I'm going to go out to Columbus, and let me change to Columbus. Probably doesn't matter, but okay. I'm going to bring some guests out there, and I don't want to get bogged down in a Herschel list or something like that. So I'll click this showpieces thing, and you know, and how big a list do I want? Okay, I don't know what normal is, but you have some options here: small, normal, large, very large, right? And you can generate a list. And there it is, January 5th at the HAS Observatory, and 25 objects on the list, right? And they're all going to be most of them are going to be pretty easy. It's got one Orion Nebula undetectable.
Completely undetectable.
That's curious.
It's behind a tree, Bran. That's
Yeah,
why.
exactly. It knows exactly where that tree is.
Yeah, that one tree.
That is hilarious. That's got to be a bug right there.
It's a sequoia, and it's a mile and a half away.
You can see the Orion Nebula naked eye.
Yeah, you can.
We are doing live bug tracking for the software.
I think, sometimes I feel like SkyTools 3 was less buggy. Oh, well.
The 4 is a new version. But yeah.
It's not that new anymore, but the
It's
guy,
really not, yeah.
he split the product up. So with version 3, it was one package. You had, a cheap version and an expensive version, but it was, whether it was visual or astrophotography, it was the same version. But with 4, he decided to separate them, and he put out the astrophotography version like
first,
a year or two before the visual one was released. And I just feel like the visual one is, sometimes suffering a little bit, but I still love it.
Clearly, yeah, you've done a lot of work on it. Like I said, when Bram gets into his mode over there, you'll just see him coming in and out of his hut, just hitting the objects.
Yeah,
you really can't bother him because
get out of his way.
He will attack you.
Yeah, you don't want to be on that path between me and between the telescope and the observing hut.
No, it's not pretty. I've seen it happen, and people have been ran over by Bram, trying to make it out to his scope. So, but yeah, he takes it seriously.
Over.
Yeah, been brammed over.
Brammed over.
You gotta watch out.
But I have a new setup now. I'm set up to have this tablet and a Bluetooth keyboard mounted on my observing ladder. So as long as it's not too dewy, I'll have this stuff right out there at the telescope, and it'll speed things up a lot.
What are the other cool things? Oh, go ahead.
Sometimes when there's not too many stars in the field, it's pretty easy to find the object that you need, right? But other times, like when you're working in the Milky Way, oh my gosh, you get over there by Sagittarius and you're looking for a quasar,
or galaxies in Virgo.
One of the many points of light, It's like, which one is it?
It's like, wait, which galaxy is this?
You really need to study it and verify the field. So it's really nice to have a detailed chart right there at the eyepiece.
The other thing too is when you get some advanced telescopes and whatnot, you can actually control the telescope with the software and with, Starry Night Pro, Sky Safari, and things like that. So, one of the nice features is if you've done the alignment, you can click on an object and say, go to it. And it'll go to it based on what you're looking at in your iPhone or your laptop or whatever else, which I thought was pretty dang neat.
Yeah. Yeah, controlling the telescope is something that if you do have a go-to setup with a tracking mount and all that, you can tell SkyTools will do it. Sky Safari will do it.
Yeah.
I think even Stellarium will control a telescope.
Stellarium will, I believe. Carte du Ciel might. I know Starry Night does.
Yeah, whatever it is.
Yeah.
Never used it.
Which is cool because you can track an object, which is just absolutely amazing. One of the things I want to try is, with and let me show you here. I don't know if you guys have ever done this before, but we've seen some images of folks who've done this. Let me bring this up here. And this is Starry Night Pro, and or Pro Plus. I've been using this software for a long time. This is planetarium software. I can kind of zoom in and look at different objects. Click on an object. Change the the views. I'm zooming in on the Orion Nebula here. Those kinds of things. But if you right click on an object, and I can center, and if I had the telescope set up, I can tell it to go to it and things like that. You can change the views on these things, and if I zoom out just enough here, what do you see there? Can you make it out, Will? It's a Starlink satellite.
Hashtag blame Travis.
Blame Travis, exactly. Here's another one there. I wonder if you can actually use these programs to track satellites like that.
Oh, totally, yeah.
Yeah, we've got to try that next time.
Correct, except for somebody at the top of SpaceX might not be giving us the proper. Yeah, but that's a different subject for a different talk, isn't it?
That sure is. But anyway, I thought that was pretty cool. We should give that a try next time we're out
We should, yeah,
observing. Yeah.
and try to purposely get a Starlink,
A Starlink, yes.
interception. Yeah, instead of just
And,
accidentally getting it.
the whole time. It's like you're purposely just blocking my view on everything that I'm trying to find to look at right now.
Hashtag blame Travis.
Hashtag blame Travis.
Yep. Those of y'all that have been around for a little while here on Deep Sky Dude, y'all know exactly what I'm talking about.
Yeah.
If he was here, he'd be like, "Yep, I'll gladly accept that." Yep.
Blame me.
But there's a lot of tools out there to use, y'all, and you know, it might not always be the best idea to just go out and start buying gear, even though us three on here do that probably too much. We have a level of experience where that becomes a benefit. So, but if you're inexperienced, the best idea sometimes is to maybe not buy too much. If the money's burning a hole in your pocket, do what you got to do, because if you have that much drive and passion, you could probably make a kid's toy telescope work for you.
Yeah.
It's all about, like Joe said earlier, that the best telescope for you to get is the one you're going to use. The one you're going to put outside more often than not. And that's what it takes, man. These things don't set themselves up. You buy this nice telescope, you set it up in the living room, you're like, cool. And then you're like, well, I don't want to take it down, because then I'm going to take it down and put it outside and do this whole process again. So it ends up sitting in the house for far too long. Yeah. So just remember that, when you get these setups, you do have to drag it outside, put it out, deploy it in the field, use it, and then put it away. And in doing that, you get that muscle memory of like, well, where does this piece go on here? Oh, it goes right here. And then you bolt this down, and then you turn this on. And that muscle memory, I mean, it comes quickly. And for me, even as an intermediate amateur astronomer back in the day, I had no idea how to use an equatorial mount. I knew the general idea, but even when I bought one, I had to buy it with a loan from my credit union because I couldn't afford it. And then I got it, and I was like, what do I do? And then it was like, okay, is this right? Yeah, okay. No, that's not right. And, it was kind of that thing. And then after, I don't know, 5-10 setups, I knew exactly what I was doing, because I knew what didn't work and what did work. So trial and error, learning from others in an astronomy club, huge, huge.
Yeah. And look, the whole theme of tonight's live stream is gear. And I can't let this, go unmentioned, but books. We live in an age where we try to look everything up online and whatnot. Mm-hmm. And those books by Terrence Dickerson, or, the Turn Left at Orion and those things, I got a ton of benefit out of those books and reading them and becoming a better amateur astronomer and learning how to use my telescope better by reading some of those books. And they're still useful today, right? It's not one of these things where it's like, you can just do all this online. Yeah, The Backyard Astronomer, Turn Left at Orion, or if you're learning the constellations, the Constellations by H.A. Ray, the same guy who wrote the Curious George books. They're just indispensable. You can't become a better astronomer. You can, but it's much more difficult without having some of these tools that have helped countless astronomers, amateur astronomers along the way. So,
and Sky and Telescope magazine,
Sky Telescope magazine, exactly. Yeah. Yes, absolutely. So there are a lot of resources out there when we're talking about gear, things that you want to add to your tool chest. Those books and those magazines and whatnot are, like I said before, certainly indispensable. You want to make sure that you've got access to these things, whether you're checking them out at a library, you're borrowing them from a friend, or buying them on your own. They're indispensable tools.
Absolutely. It looks like as we're closing it out here, it looks like we may have a final question, or if y'all do have some questions, get them in now, so we won't leave you hanging if you do have something that's just pressing you need to ask. Gaurang, did I get that right? Hello, can we pre-script a program in Stellarium to run a sequence of moves with a voiceover? I think you can do something like that, or can you suggest a software where you can do that? So one thing I will say about that is there's all kinds of scripts that you can run in Stellarium, but I have no experience with that. But Sky Safari Pro, which is what I use, and maybe some of these other programs that Joe and Bram use, do have on certain objects like brighter stars, nebulas that are brighter, and those sorts of things. Especially Sky Safari Pro has, I think they call it Celestron audio, maybe. Where you can click on the info of an object, go in there and listen to to some information on that object, made by it's Celestron, I'm pretty sure. And so they've gone through like all the major stars, the moon. I mean, geez Louise, Saturn, just so many things, even some brighter galaxies like the Andromeda Galaxy and some others. And they have narration. Not a whole lot, but there is some there. So yeah, there is something like that in there. But as far as Stellarium goes, I'm not exactly sure. Stellarium is pretty open source. It's pretty amazing. There's a lot you can do with it. So I don't know. You guys may know more about that than I do.
Yeah, I haven't done it myself. Go ahead, Bram.
Joe, go ahead. Okay, I'll go.
Yeah.
Sky Safari has an impressive amount of background information about objects. Some really good detail. There's like for the Eastern and Western Veil Nebula, like there's paragraphs and paragraphs about the history and what's up there. It's fun to have in the field. And get that information. That kind of information is completely absent from Sky Tools. You know, you'll get distance and what class of object it is, but like that's about it. So yeah, I'm not sure if that's what you were looking for voiceover or if you meant like voice commands.
Yeah, and I know if you're on a Mac, you can use Apple, or you can use dictation for the Apple scripting part of it. So if you can somehow get this Apple scripts to execute Stellarium functions and things like that, then yeah, you can certainly do that.
Yep. And then he says we need to record voice in local Indian language to run in the program. Yeah, and you would have to use exactly. So you would be kind of responsible for that sort of thing, which would be an invaluable tool. I would think. So if that's something you're into doing, that may be something you could even market.
I see what you're saying. Can we? Yeah. So can we pre-script a program in Stellarium to run with a sequence of moves with the voiceover? Oh, so as it's moving over, almost like a planetarium show, I think is what he's talking about.
Yeah, and then in specifically in Indian language. Yeah, and I mean you could do that. I wouldn't know exactly how to go about that, but there are forums for Stellarium like all over the place that would really probably be helpful for you there.
Yeah, and there's video cap. So if you're doing that, you can actually just capture, the screen if you're using a program like, oh gosh, what is it? Camtasia, and they have other screen capture software. So you can actually do that and then speak through. So it'll capture the voice. It'll capture what's on the screen. You can actually have a webcam in there too if you want to capture, your image if you want to go through that. And then when you're all, said and done, you can package it up as an MP4 file or something like that and deliver it that way. So that's one way you can do it.
Yeah, absolutely. And welcome to the show, Star Fox. You're a little late. We're about to head out, but welcome. Glad to have you. And thank y'all for the questions. We appreciate questions here because it gives us something to talk about besides the mindless ramblings that we have in our brains.
Oh, look who just jumped in.
Yeah. Oh, this is a different Travis, but
it's a different Travis. Never mind.
Different Travis.
Well, we still love Travis Hall. Hey, Travis, how are you?
Blame this Travis for everybody having a good night.
Yes. Travis Hall gets the blame for everything else other than Starlink.
Blame Travis Hunter for Starlink, but Travis Hall for everything else.
Just hashtag blame Travis works.
Yeah.
Regardless.
But yeah, thanks for joining us, Travis Hall. Have a good night as well. And Star Fox, thank you for joining us. Thank you, Gaurang. I don't know if I'm saying that wrong, and I'm not trying to intentionally mispronounce it. I'm just bad at names. Joe, I think, right? And Brahm. Is that how it is?
Brahm.
Anyway, Brahm. Brom Weissman.
I'd like to know
Bram
if it's Marcia or Marcia.
I think it's Marcia. But
I'm
again,
betting Marcia.
Marcia, Ms. Andrews. If it's Marcia, put A in the comments. If it's Marcia, put B.
I think they left. But
Oh, really? Okay.
yeah, I'm pretty sure I will mispronounce a name, even not on purpose. So I'm probably wrong.
I've mispronounced my own name, so there you go.
I'd like to say a few things in response to Vishal's question at 11:07. I don't think we touched exactly on this. He says, if I use untracked and then stack the images.
Oh, yeah.
So,
I was going to mention that.
So there's a few things to consider here. First of all, the higher the magnification that you have, the more stars are going to drift in the field of view during an exposure. And depending on the mount, like if you have an alt azimuth mount, let's say you could track an object perfectly with an alt azimuth mount, keep it perfectly centered in the field of view. The one problem is that the field, like this rectangular field on the CCD, is going to be, not following the rotation of the sky. It's just going to be panning across the Earth. And so the field is going to rotate on the CCD as you're taking your images, whether you're stacking or not. Okay. So that's an issue. There may be software that can derotate. There's a mechanical device you can get called the field derotator. It's yet another piece of the puzzle, right? So in general, for the best results, if you want to get into imaging, you're going to want an equatorial mount that tracks. You're going to want to have a good alignment, and you're going to want a mount that's sturdy enough for whatever kind of equipment you're carrying. You've got to consider the weight of the telescope, the weight of the camera, all that stuff, right? So, I mean, you can have, I guess, a limited degree of success untracked and stacking, but keep your expectations reasonable. If you really want to get serious about it, you're gonna want an equatorial mount for sure.
Yep, with a good polar alignment, and
Yeah.
everything Bram said there is true. I would just go the short answer there and say no, because of everything Bram just mentioned.
Yeah.
You're gonna get frustrating results. You'll get results, but they will be very frustrating. You're gonna
you're not gonna wow your friends with the results.
No. It might be cool art. It might be cool art to kind of have that spacey vibe with everything kind of messed up, but it's not what we all want, I guess, in that context of stuff. So you need, like Bram said, everything he said is true. An equatorial mount that has a really solid polar alignment, that's tracking, and stable, and everything is working. Then you're going to get good data, and then you take the good data and stack that, and that stacking allows you to reduce the noise and take all the nonsense out of the image and give you that beautiful nebula, galaxy, star cluster, whatever it is you're after. That's what will come later after you stack all those images together. So yeah.
And equatorial mounts for visual observing, not a fan. They're awkward. They can't, the cheap ones, they can't get out of their own way. The slow motion controls get in the way of the counter. I mean,
the angles could be a little weird. Yeah. Just depending on when you're moving from one object to another. I totally agree with you, Bram. If I'm doing visual observing, I prefer some sort of Altaz or Dobsonian type mount as opposed to, equatorial.
Yeah. Yep. Everything they said.
Yeah. Fist bump, Bram. Oh, this way.
That's not a fist. That's an elbow.
Elbow bump, I guess.
We don't even know body parts here. Why are we giving?
I was trying to go down to Bram.
He's punching down at you.
Yeah, this is there you go.
Those fists are not to scale. Your entire fist was in Joe's entire body.
I should have been like over here. Not so close to the camera. Yeah. It's a
Anyway,
learning curve.
yeah, it's what's
Like
weird.
everything
Everything's kind of
else.
backwards too when you're looking in here, but
Right.
we appreciate y'all hanging out with us, man. We'll try to do stuff like this. You know, we've done a lot of these in the past, and these won't be the last few. And in fact, I think in 2022, which I think is the year we're in, we'll probably do more of these. You know, so if y'all do have questions about, you know, your telescope or your setup, or you may want to get into purchasing something, you know, let us know, and then maybe we'll keep track of those as they come in, and address some of those kind of questions in a live format. Of course, we do enjoy helping people out on the fly, which is kind of what we did here, which is pretty cool. And I mean, basically, you know, we just gotta play off what y'all have needs for. You know, if y'all have a need to learn an equatorial mount, we can help you out. If you don't have that need, then maybe you have another one. So, and hopefully we can help, because that's why we're here. Because all three of these dudes, myself included, but these two dudes with me here, are extremely passionate about astronomy, and we want to foster that in you guys. And and if we can do that even a little bit, then we've done our job. And so hopefully we've done that tonight. And thanks for getting this all together. This was really Joe's idea. You know, he was like, "Hey, do y'all want to do a live stream?" And I'm like, "No, I'm lazy. No."
Well, it's been months since we've done one, right? Will, you and I spent 3 nights in a row on the virtual Texas Star Party, and I don't think we've done anything since then, have we?
Uh,
Maybe.
not a
I
live,
don't think so.
live stream. I don't think.
Yeah,
No.
yeah. I don't think we have. So, it's always good to get with you guys, chat astronomy, and get the chance to meet lots of other people around the world, and take questions from them as well. So we love doing this. Like we said, we're just regular folks like everybody else. Just happen to have been doing this for quite some time, and we're hoping, like you said, Will, to help others along the way and get them totally ensconced in this hobby that we love. So I had
That's
to throw
right.
the word ensconced in there. So
Yeah, I'm gonna have to go look that one up because I don't know. That may be a naughty word. I
I
don't.
could just be, totally making that up, right?
Yeah. It means to hide or something. I don't know, but no. We don't know very many words here either, but that's okay.
Yeah.
That's part of it. But and hey, Bram, thanks for joining us, man, from
My
all the way
pleasure.
in Katy, Texas.
Next
What do
time
you
we'll
got?
have to talk about collimation.
Oh, that's a hot button issue.
Oh yeah.
I think
Maybe we
we
could do a
all.
show on Dob setup.
Mm-hmm. Yeah. Yeah.
Maybe
Dob
I should
setup, and then we could do
say a
another
few
one
more
for
words
Schmidt
about
setup, and
collimation before we
yeah.
cut off, just because it's important. So, Newtonian reflector telescopes in particular do require regular, maybe not so regular, semi-regular collimation. What that means is alignment of the mirrors. And actually, I responded to somebody's post earlier today or yesterday where she says, you don't need to collimate a new telescope. Wrong. There's, these things are coming from halfway across the globe, bouncing around in a shipping container. Do not expect your collimation to be perfect out of the box. And you're going to transport it around. And I always check collimation on my Newtonian every time I use it.
Yeah.
Collimation used to scare the crap out of me. I had no idea what I was doing. And I thought, am I going to mess things up? Okay, first of all, you're not going to mess anything up. Anything that you do can be undone. Having the right tool. Here we go. Never collimated my new Orion XT8i. Scares me. Okay.
You need to.
Do yourself a favor. Get yourself a laser collimator. It doesn't have to be a very expensive one, but you're going to want to check it when you get it to make sure that that it itself is collimated, right? So what I've got here is a Howie Glatter laser collimating system, and it has two main components. There's the laser, and then this is what he calls the tube lug. This thing, I'll get to this in a second. Step one, if the laser's new to you, or if you're ever in doubt, the first thing you want to do is put this thing in your focuser And this is just my little adapter, my 2-inch to 1.25 inch adapter, which is going to go in my focuser. I'm going to stick that in there. I'm going to turn the laser on, and I'm going to look at the dot that this projects on the primary mirror, and I'm going to spin the laser. Okay. I'm going to try to make sure that the laser's not wobbling around in there. And one of the nice things about the glider stuff is it's super high precision, so it's a really snug fit. They don't wobble much anyway. But you're going to want to just be careful that you're not introducing wobble while you do it. You want to watch to make sure that the dot is not wandering around while you're turning it. If it is, okay, it might be slop in your focuser. Try to hold your focuser steady to make sure that that's not the issue, and then turn it. And if the dot is wandering around, you've got a bad laser. Okay, just return it and get another one. All right, once you got that out of the way, the first step really, okay, is to look at where the dot is on your primary mirror. Your most primary mirrors are going to come center spotted from the factory. So when you look at the mirror, right in the center of it is going to be a little white papered donut, like a notebook reinforcing ring. In fact, if you ever want to center dot a mirror yourself, that's what I recommend you stick on there. And then there's going to be some adjustment screws on the secondary mirror, the little mirror up near the eyepiece, okay? The one that's at a 45-degree angle. So you're going to want to adjust those screws until that laser dot is in the center of that paper target, okay? That's the first half of the process, all right? The second part, if you have the glider system, you're going to stick the laser in here, and there's a little lens in here called it's like a little Barlow lens. And what that's going to do is it's going to blow the laser light up. So instead of being a dot, now the primary mirror is going to be flooded with light, and it's going to return the shadow of that paper target back to this white target. Okay. So hopefully you're going to see the silhouette of that paper target somewhere on here. And then you're going to go down to the bottom end of the telescope behind the primary mirror. There's going to be 6 screws, 3 lock screws and 3 adjustment screws. So you're going to loosen all the lock screws, and then you're going to start playing with the adjustment screws to move that silhouette over the center of this hole. And once you get it there, tighten up your lock screws. Observe this while you're doing it to make sure it doesn't wander any, okay? And once you've got it dialed in there, you're done. So effectively what you've done is you've made the laser leave this aperture, hit the secondary mirror, go down to the primary, come back and hit the same spot on the secondary, and back into this hole. The laser's returning back on itself. That's collimation. And then you can visually confirm this by defocusing a star. Pick a moderately bright star at moderately high power and defocus it so that it becomes fat. If you go too far, you're really just going to see a big white blob with a donut hole, a dark spot in the middle, and really you're looking at the primary mirror at that point. But as you start to defocus it, you're going to see these little diffraction rings. And if they're all concentric, you're collimated. Try going in and out of focus both directions when you're checking collimation. And that's my short spiel on collimation.
It's all accurate. I can confirm. One, and also one, I will say it may sound a little complicated if you're not kind of watching it be done. Once you see it done a couple of times, it becomes second nature.
Oh, yeah. I collimate in less than a minute.
Yeah. And we all do it at the beginning of the night. I do it a couple of times at night, because as the temperature changes, stuff can flex and move and expand and contract. So, but like Bram said, it's something that you should always do to especially an XT8, which is a Dobsonian.
Yeah.
Because
think of
those
it like
move.
Think of it like a violin. You're not going to buy a violin and not learn how to tune the strings.
Mm-hmm. There's an analogy there that you could have used that I think would have been better, but I can't. I can't
guitars on the wall there.
There it is.
Oh, look at that.
Right there.
I didn't know where you were going with
Look at that. What is that?
Look at that.
Yeah, that's great stuff, Bram. And especially like you said, with Dobsonians, it's something that you're going to have to do at least nightly. Some people will do it nightly. I like to do it before we start the observing sessions. When I was purely a Schmidt-Cassegrain guy, I would do the star focus defocus trick that Bram was talking about. And usually the Schmidts hold their collimation much, much better than a Dobsonian will, just because, much more rigid when you've got the secondary mirror, on a corrector plate or something like that. So not as many opportunities for movement and getting knocked out. So, a little different there. So it really depends on what kind of telescope you're using as to how frequently you want to, actually do the collimation. But certainly before you start observing, you want to at least test. And then to your point, Will, make sure that you've had the opportunity to bring the mirror to temperature, right?
Mm-hmm.
So if things are kind of out of whack, that optical alignment may be out of whack as well, which could affect collimation.
Very true.
Or what you see for collimation, I should say.
Be right back.
Yeah.
Okay, we're gonna do more collimation. Oh, I thought we were.
I don't know. Did we lose Bram?
He's gonna go on Cheshire collimation now, I guess.
Well, and the thing is, the tools for collimating a Schmidt-Cassegrain are different. So you can't use that laser, that Howie Glatter laser in the tube lug for a Schmidt-Cassegrain. They use something completely different that blows it out on a wall, and then you've got to mess with screws based on the projected image that you see on the wall there. So
yeah,
Bram
that's
is back.
Beast. That's a whole other beast. Yeah.
Oh yeah, completely different. And those collimation tools are pretty expensive.
If you
That's
have
why
a
the defocuser.
Yeah, if you have a Schmidt-Cassegrain or a refractor, don't even mess with it. The only scope you should ever be collimating is a Newtonian reflector, in my opinion, as an amateur for sure.
That's what I
will
like
say
about
this.
a Mac Cass.
Yes.
Mac Cassegrains, they don't lose collimation.
If you have to collimate your Maxitov, then you might as well just
send
trash
it back. Yeah, it's a factory refix. Yeah, absolutely.
Yeah. With the Schmidt or Cassegrain, like I said, I will just do the star, focus defocus once the telescope is at temperature and I don't have all the convection and everything in the tube. But once I'm there, like I said, man, it's rare that I actually have to do collimation there. All right, what do you have there, Bram?
This is another collimating device. This is from Orion. It's a collimating eyepiece. Some people call it a Cheshire, and it requires no power. And it has some crosshairs down the bottom, and it has a little pinhole for you to peek through. And this cutout with the diagonal thing really is to collect light and throw light, I guess, or to make this visible. You can see this as you're, and so it's kind of a similar deal. You're just going to put this in your focuser, and you're going to look in there, and you're going to hopefully see that the that center spot on the mirror is centered over the crosshairs, and then you're actually going to be able to see your own eyeball. You're going to see your own pupil reflected, through the mirrors, right? So that's another way you can confirm if you're collimated or not. If everything is centered when you peek through this, and you could do the collimation using this thing. It's a little. It takes some getting used to figure out what you're looking at, because you're going to look at the secondary mirror and you're going to see the outline of the secondary mirror. And you want to make sure that you can see all of the secondary mirror. That's the first thing you look for when you peek in here. Can I see all of the secondary mirror? If you can't, you may want to move the secondary mirror in or out of the tube, or you might need to rotate it if it's cattywampus, And then you're also going to want to be able to see all of the primary mirror in the secondary mirror. So it's an iterative process. I can do it these days, like no big deal. It was weird to figure out in the beginning, and I will say that the laser collimation is just easier. It's fast, it's easy.
100%.
Yeah.
So with the Cheshire, you want to see your eyeball before you try to see Uranus, right?
That was the joke we were waiting for tonight.
I'll be here all night, folks. Thank you.
Otherwise, it's blurry and you won't see any detail.
Oh,
We are highbrow.
Of
We are
course.
highbrow astronomers here. Very good. Well, if there's no other questions coming in, and I didn't have anything else. I don't think you guys maybe had anything else.
Most telescopes too. A Newtonian is probably coming with a collimation cap, which is dead simple. It's just a little plastic cap that sticks in the focuser. It's going to have a reflective surface on the inside, and again a pinhole. Kind of the same concept as this. If that's all you got, it's better than nothing.
Yeah. Don't
That's
be intimidated by it. Yeah.
Yep. And Garang, thank you so much. It's a great show, Will, Joe, and Bram. It's very informative. Keep it up. Thanks. We sure will. I mean, like we said before, we do these, randomly when we feel like we need to. We don't necessarily have a schedule for these sorts of things, but that's kind of the fun of it, right? We're just like, surprise, we're live, and that's kind of we like to be like that. Surprise, we're here, and that's the way that
Uranus.
surprise, Uranus. It's Uranus. That's how the real highbrow astronomers.
Oh yes. I'd never call it Uranus unless there's a joke to be had. So.
And it's always a welcome joke.
That's it.
It's a little far off though, that joke.
A little bit.
Just a little bit. It's a few 100,000 miles anyways. Thank you. We appreciate that. So thank y'all for joining us, man. It's always a good time hanging out with you guys, of course. And hanging out with y'all in the chat rooms. Be sure to follow all of us on social media. I mean, we're all on Instagram, TikTok. I think most of us are on TikTok anyways, or all of us.
You have to do that.
Oh, you need to create a immature astronomer TikTok.
We can create our own, little astronomy dance, that whole thing.
The Cheshire dance, which is
the Cheshire dance, the collimation dance. All the kids are doing it.
Collimate dash scope. No. But yeah, we have social medias and you can see it all there. Deep Sky Dude, the Astro Joe on Instagram. We're all on Instagram. So just go there, follow us there and start there. And then, you can branch out when you need us. But a lot of y'all are probably watching us on either Facebook or YouTube, whether it's on Joe's platform or mine. So please do subscribe to us there, and because you'll get notifications when we do this again, right. or when we upload a video or whatever. Which I'm editing now, the Okie-Tex Star Party video. So that's gonna take me a little bit though. It's like 8 hours of footage that I took out there, which is way too much. Because I'm gonna have to whittle that down to about an hour and some change. So. That's coming soon. And Joe, do you have anything coming up astronomy-wise soon, or?
Nothing yet. Well, not for me personally. Most of you guys know, I'm president of the Houston Astronomical Society. We've got our general meeting coming up this Friday. We're going to go have a walk through the Galileo Museum with Bill Spitzeri, who's a wonderful presenter. The guy is just absolutely, just fantastic. So if you get a chance, go to the Houston Astronomical Society Facebook page. We'll live stream it there. And that's it.
Awesome. Bram, you got anything coming up in the future?
Just looking forward to Texas Star Party.
Oh, yeah.
Oh, and by the way, tomorrow or in 1 minute is the deadline.
That's right. It's
yeah. So if you didn't pre-register, you're gonna have to watch the video later from all of us.
That's it.
But yeah, January 6th is the deadline, so you have 1 minute to get over there and pre-register. Good luck with that. And because we were excited for the Winter Star Party, but the Winter Star Party has been canceled this year down in the Florida Keys. So it looks like the next one will be Texas Star Party, like Bram said, and you'll find all three of us there if you're there with us, and we'd love to meet y'all, hang out with y'all, share some views. Just don't get in Bram's way when he's coming out of that hut.
I'll mow you down.
He will. He'll mow you down. But if you ever just look in his hut and see him passed out on the floor, which happens sometimes, once he's run out of juice, you know, you can probably bother him then, and he won't run you over as much. So that will happen though. But yeah, so thank you guys for watching and for all the awesome questions. We appreciate that stuff so much. Until next time, I guess we'll see y'all right back here on these platforms, the Facebook or the YouTubes, wherever y'all are watching us from. And excited to hang out with y'all. Joe, send us off with some words of wisdom or something.
Oh, words of wisdom. Yeah. After I had that Uranus joke.
That's what spurred that. Yeah. Make us think.
Let it be. Let
Yeah,
it be.
there you go.
Let
Hey,
it
look,
be, let it
we keep
be.
thinking this COVID thing is behind us, and then all of a sudden we've got a new variant popping up, and it looks better, then it gets worse. Just you always say this, Will. Wash your hands. Be nice to one another. Show some compassion for your fellow human, and hey, man, we're on this ball floating through space with one another. Let's just do it in a nice way.
And
That's it.
don't look up.
No, do look up.
Do look up. Absolutely.
If one more of y'all
Absolutely.
puts don't look up on my Instagram or TikTok, I will block you.
Yes.
If one more person does that, that's it. I've had enough. Do look up. I need you to look up. No. All right, guys. We'll see y'all on the flippity flip.
Thanks for joining, y'all.
See you soon.